Yes, ma'am.
Okay.
Yes, ma'am, it is visible.
Okay, so typically the second session of your week will be called a solve with us session. So in this session, we will solve some selected problem. And yeah, any doubt you
Hello?
can ask.
Hello?
Yeah. Yes.
Ma'am, can you take a practice assignment doubt, ma'am, today?
No. Today we will solve some selected problem, and then tomorrow again there will be one class. In that class, we will take your doubts from all the assignments, activity, practice. Okay.
Today's session theory session, ma'am.
No, today I will cover rest of the theory portion and solve some problems. And tomorrow will be the open session. So in the open session, you can ask whatever you are facing problem with. Okay.
Okay, ma'am.
Okay.
Okay, ma'am.
Yeah. So let us start.
Okay, ma'am.
Yeah. Okay. So this is the first question. Now you know what a irrational number and what a rational number is. So just to recall, rational number means we can write it in P by Q form, right? P by Q form, where P and Q both were from the set of all and Q was not equal to 0, right? It was the definition of rational number. Now, this is the question. You have to find out the number which are rational and which are not. Okay, so I'm giving you 2 to 3 minutes. You just take your time and let me know. Okay.
Hello, ma'am.
Yes.
Ma'am, I want to ask that tomorrow is math session because
Uh,
ma'am, in calendar there is no session for tomorrow for math.
okay.
There is Hindi
So,
session of math, ma'am.
we have to schedule it. Maybe probably tomorrow will be a session, Hindi session from
Yeah,
4
ma'am.
to 6.
Yes, ma'am.
From 4 to 6, there will be Hindi session, and Tuesday it will be the open session. Okay.
Yeah, ma'am. Tuesday there is a session.
Yeah. Tuesday we have the open session, please. So that you can get some time to solve the problem and then we can have a proper discussion session. Okay. So, so let us start with the first question. About the first number. Is it a rational number or not?
Yes.
Is it a rational number?
Yes, madam.
Why?
2 into the 6, I think it should be 2 to the power of 1 by 3, na? So it will come down, so it will be 6 by 3. So
Yes, ma'am, first number is rational. It is 2 and 1/3. So it will become like 2 times 3, 6, 7 by 3. It is correct.
This is 2 and 1. This is not 2 and 1/3. This
Oh,
is
sorry,
2
ma'am. 2 to the power 1/3. Sorry. It is irrational, ma'am. 1/3
Yeah.
of, yes, ma'am,
Cube
third power
root
of
of
2.
Ma'am,
Oh, sorry, ma'am.
it is irrational, not a rational.
Yeah, right. So this is similar to the root 2, right? So this is a
Yes, ma'am.
irrational number. Okay. What about the
Cube root of
second
2.
number?
Ma'am, this is rational. This
Yes, ma'am. They
simplifies
are rational.
to 6.
So we can apply the A plus B and A minus B formula, right? So we will
Yes,
get
ma'am.
minus 2 equals.
Is, which is
The
6. Yes,
third
ma'am.
number is also rational, right?
Yes, ma'am.
So this is
Yes,
the rational
ma'am.
number.
Ma-
This is the
And
rational
the
number.
next one is irrational, ma'am. Root 2
Irrational.
upon root 3.
Yeah. So
Irrational.
this is a rational number. And what about the
Yes.
next number?
Rational.
And this is also irrational.
Okay.
Is it?
So what can we do? We have, let us check. Okay. So we have
Yes, ma'am.
root over 8 minus 2 by root 2 minus 1. So what can we do with root over 8? We can do with
2 root 2 we can write. Yes, ma'am.
minus
Root 2 minus 1.
root 2 minus 1. Then we can take 2 as common. We will get root 2 minus 1 by.
Oh, sorry, ma'am. Yes. It is a rational number. We are left with 2.
Yeah, right. So this is a rational number. And what about the next one?
Ma'am, this one I was solving and
Ma'am, how did you solve 8 root 2 minus 2? Can you please explain?
Yeah. So we can rewrite root over 8 as 2 root 2, right? Because root over 8 is 2 cube. So we can write it as 2 root 2. Now you can take 2 as common. So you will get root 2 minus 1 in the numerator, and in the this portion is also root 2 minus 1. So this we cancel out. Then in final result, you will get a 2. Okay, which is a rational number.
Ma'am, the last number I think is irrational.
This one?
Yes, ma'am. Minus root 48
Yes,
upon
ma'am.
root
It's
27.
irrational.
Okay.
It solves out to 2 root 2
So
upon 3.
27 we can write as 3 root 3 maybe, right?
Yes.
And
Yes, ma'am.
48 can we express in term of root 3?
Yes, ma'am. There is root 3 in 48. It simplifies to
So if
4
you
root
as
3, I
divide
think.
48 by
Root 3 gets cancelled,
Yes,
no?
ma'am. Yeah.
1 and
Minus
8,
4 upon 3, I think.
right? So we
4
will
by
get
3.
4 root
Minus 4 by 3.
right? Is it fine? Yeah.
no, ma'am. I think
Root 3 get cancelled, you will get minus 4 by 3.
Yeah, minus 4 upon 3. Last one is rational.
Yeah. So this is also a rational number. Is it fine now?
okay, ma'am.
Because 27 is 3 root 3 and 48 is 4 root 3. So root 3 will be cancelled out. Then in a result, we will get minus 4 over 3. Okay?
Hi, ma'am. I have one question.
Mhm.
So I'm not sure if it's already covered, but pi is said to be irrational number, right? However,
Yeah.
it can be represented as 22 by 7. 22 by 7 is a rational number, right?
Okay, so 22 by 7 is not exactly pi. This is actually approximation of pi. Okay, so 22 by 7 is not exactly what pi means. So because we need some value, so we take some approximate values. Okay, so 22 by 7 is the approximate value of pi.
Okay, understood.
Yeah. Any other doubt? Anything else? Okay, no, right? Okay, so we can, yes. Okay, so let us just move to the next question. This is a solution written, okay, so if you want, you can check. So these are some concept, complement of set, and I guess you know what a complement of set is, right? That means sometimes we have a universal set, which is the white shaded portion, and suppose we have a which is the black portion. So the complement of the set is basically the universal set except the particular set.
Yes, on the set A,
So
except
this
the
is
set.
complement, yeah. And subtraction is again same, like you again suppose you want
Only in A.
subtract, yeah.
Yes, ma'am.
So A, suppose you want to calculate A minus B, that means those elements which are belongs to A but not in
But they should not belong to B, right?
yeah. So this is again we have union and intersection. So you already know about union and intersections, right? So union means
Yes, ma'am.
yeah, all the elements in both the set, and intersection means we will collect the common elements.
Common in both of the sets. Yeah.
Yeah, so sometimes we represent union as or and intersection as and. Right? So these are some formulas, and what I suggest you have to keep like memorizing this formulas. I mean, you have to use these formulas frequently during your exam and your assignments all. Okay?
Ma'am, this document will be sent to us, or how it is like?
I guess you have the document in your portal already.
Okay, sure.
Yeah, you just go to, like you can have some slide of solve with the session. So you just check. If not, then ask me in the next session.
Under supplementary content, is it?
Yeah, you can check it in supplementary content. Yeah.
Okay,
I don't remember exactly, but yeah, you can. It will be available in your portal. Okay.
Okay, ma'am. Thank you.
Ma'am, it is not available.
Not available. Are you sure?
Yes, ma'am.
Yes, sir. This particular slide is not available, ma'am, because I downloaded the
Ma'am, it's
content.
not available in our
It is in
chat
PDF
box.
format. Yeah.
Okay, no issue, no issue. Then after the class, I will share the slide.
Yeah.
Okay,
Thanks
so
so much.
you don't need to worry about it. Okay, so this is the next question because we already know about set operations. So we have to just apply our knowledge. Okay? So
Yes, ma'am.
you have this three sets and you have the cardinality mentioned here. Cardinality means right? The number of
The number of elements in a set.
Yeah, perfect. So you have to find the cardinality of m minus c. That means the elements which are in m but not in c. So yeah, what is the number of elements?
Ma'am, it should be 50, ma'am.
Yes, ma'am. 50, 70 and
Only though we need to leave those elements which are in C.
Yeah, that means we will exclude this portion from A, right?
Yes, ma'am, from M.
plus 10.
Yes,
Just
ma'am.
have to add this portion. That means we have
We have
40.
yes, ma'am, 50 elements.
15.
Right. So I guess everyone is fine with it. So let us move to the next. This is the second question. Again, you have to find the cardinality of this set. M union C.
And
40 will be.
So first you have to calculate M union C. M union C means this red shaded portion, right? And if you want to take the intersection with S, so then
it should
get
90, I guess. Oh no.
this portion, right?
110.
Yes, ma'am. 150.
150, ma'am.
Okay, just
150.
150 we have 160, any other?
110.
0.
0.
What?
150 no, madam.
150.
Yeah, ma'am, 150.
150, ma'am.
Okay. If we apply the theorems, I mean formulas, so we know that we can write this as M intersection is union.
Yes, M intersection S. C intersection S. Yes, ma'am.
Now, if I just union this two things, what will we get? M intersection S means this portion, right?
Yes, ma'am. M intersection S.
And C, like this is the right answer, no doubt. But I'm trying to solve it with different procedures so that you can relate it properly. Okay. So that means basically these three regions, the 41, the 51 and 16, these three regions are the main, you have to add those numbers, right? So this is fine. But if you do it with this method, then what we have to do?
First, we have to calculate the intersection of M and S, and then C and S, and add them both.
Yeah, right. So this will be again same, right? So this, because this 50 is basically common in both M and C, so we will not like add them twice.
Yes, ma'am.
So we will add them once, right? So
We will not duplicating it.
Yeah, right. So we will basically get 150 in a result ultimately, right? So it doesn't matter whatever the method we are following, but we will get the same answer. Okay. Any doubt?
No, ma'am.
Okay.
No, ma'am.
Okay. So yeah, this is the next question. This is about relations. What I guess, yeah. So you know what a relation is, right?
Yes, ma'am.
Yeah. So in short, if I just mentioned in one line what a relation is, suppose I want to define a relation R from A to B, that means it is basically a subset of the Cartesian product of A and B, right?
Yes, ma'am.
Any possible subset of A cross B. So this is a one line definition of relation. Now you have given set A and you have R1 and R2. So you just have to calculate the cardinality first. So for now, you can take R1 and R2 as set. Okay. So what is the first step? I guess it's obvious. You have to calculate R1 and R2 first, the number of elements.
So we will have to list out elements for each of the set.
Yeah, right. So what will be the R1 set?
1, 2, 2, 4, 3, 6.
No, the natural numbers start
4,
from
8.
0, I guess.
0, I missed on 0.
Yeah, so you have to collect it from 0. So 0, 0 will be there. Then we will go next to 1. Then 1, 2 will be there. Then 2, 4 will be there.
4,
2, 1.
Then 3, 6 will
3,
be there.
yeah, 4 and 8.
4 and 8.
7.
Will be there. And then 5 and 10 will be there. But we cannot take x as 6, right? Because we will get then y as 12, which is greater than 10. But we have the restriction a should be less equals to 10, right? Okay. So this is our R1. Similarly, we can calculate R2. So what will be the set R2?
0, 0, 1, 1, 2, 4, 3, 9.
3, 9.
2,
4 and 3, 9.
So we cannot move to 4, right? Because we will then get 16
More than 10.
Yeah. Okay. So then we have to find this cardinality. First, we will find the set R1 union R2. So what is R1 union R2? This the whole set, right?
0.
Yes, sir. Combining these two sets.
Yeah.
My answer is 4.
Except the 2, 4, everything will be there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 will be there. R1
So basically, we have to find
5.
Member which are in R1 but in not R2, right?
5.
So basically, we will just extract these numbers. So what we will get? We have to extract 0, 0, right?
And 2, 4. Yes, ma'am.
2, 4. So this 4 element will be there. Then
We
that
have
means
4
the
elements, yes,
cardinality
ma'am.
will be, yeah. So the cardinality of this R1 union R2 minus
Ma'am, we can
R2.
write this.
0.
Yes,
Yeah.
ma'am. This the expression you just wrote, we can write it like this also: R1 slash R2
Minus
union
R2.
R2 slash R2.
Yeah.
So I think
So
that
you
becomes
can write
R2,
it as R1 minus R2
R2 union.
R2 minus R2. So this you will get as
So the
5.
right thing, yes, ma'am. The right one gets
You will
cancelled
get
as 0.
union with 5. So this will be ultimately R1 minus R2.
Yes, ma'am.
Okay.
This removes the confusion when writing this combined.
Yeah, yeah. Right.
Ma'am,
Okay.
why is there a 0, 0 since it's clearly from natural numbers?
Okay, so because in this course we consider 0 as a natural number, like we start natural number from 0. Okay.
So in every questions, whenever natural numbers comes, we'll have to take 0.
Yeah, you have to consider it from 0. So normally we know that natural number starts from 1, but in this course we follow what the Python method follows, right? So that is why we start natural number from 0, 0, 1, 2 and so on. Okay.
Okay, ma'am. Thank you.
So
Ma'am, can you please
Yes, ma'am.
repeat
I
that
think
one? I understood that R1 union R2 we got it as 8, right? Then if we do minus R2, how we get 4? Just can you repeat this one, please?
Yeah, so minus R2 means you have to basically exclude the number which are in R2, right? So you just have to check.
Oh, okay, ma'am. Got it, ma'am. Got it, ma'am.
Yeah.
So remaining is 4. Yeah, got it, ma'am. Thank you.
Remaining number is 4. Yeah. Okay. Anything else? Any other doubts?
Ma'am, R1 union R2 is 1, 2, 3, 4, right? And R2 is already 4 cardinality. Both the cardinalities are 4.
Yeah.
Then 4 minus 4, it must be 0.
No, this R1 union R2 will be, I mean, all the number in R1 and R2, right? So you will get 0, 0, then 1, 1, then 1, 2, then 2, 4, then 3, 9, 3, 6, 4, 8, 5, 0. All the number in R1 union R2. So you will get total 8 members. Now you are excluding 4 members. Okay.
No, we are
So
excluding 2 members, like 0, 0, and 2, 4.
excluding 4 members
After
from
that remaining
R1
4.
union R2. So in R1 union R2, we have total 8 members. Okay. And now you are excluding 4 members. So we will get 4 members, right?
Excluding means removing, right?
Yeah, removing. Yes.
So here only we are counting the numbers, right, ma'am?
Yeah.
We are only counting the members in the group.
Yes. Right.
Okay.
Yeah. Okay, fine. All of you
Still
are
I didn't get.
Many students in this course are confused that why we in this course 0 is included as a natural number, because
No,
sir,
that's no.
the professor has given a good reason. Ma'am, can I say a little bit? The professor has given a good reason about it, that we use 0 as a counting number as well. Like if in a room there are no boys, then we can say there were 0 boys in the room.
Yeah.
So that's why we have included 0 in our natural set.
Okay. Yeah.
Yes,
Okay.
ma'am.
Yeah, that's good reasoning. Okay, so if you are fine with it, then let us move to the next question.
Yes,
Excuse me,
ma'am.
ma'am.
Yeah.
Ma'am. Ma'am, like when we are doing the union, please scroll down.
Yeah.
Ma'am, when we are doing union, there is a repetition like 0, 0. So
we will
when
not
we will take only one.
Yeah, we will take only one.
Okay, thank you.
Anything else? Any doubt? Any other doubt?
No, ma'am.
Okay, perfect. Okay. Next we have about relations, right? So we know what like the types of relation, right? That means symmetric, reflexive, transitive, and all. So if you have any doubt with the concept, I can repeat it. Otherwise, I will go to the problems directly.
Ma'am, I
So,
have one question. Ma'am, can
Ma'am,
you please
I have a doubt in
explain
the
the
equivalence relation, ma'am.
okay. Yeah. One by one, I will explain equivalence relation.
Ma'am, I have the same doubt. I just want to know the difference between equivalence relation and equivalence class.
Okay.
Anji.
Okay.
Ma'am, can you please repeat all the properties of relation once?
Yeah, sure. Okay. So let us just start with reflexive relation. Okay. So reflexive relation means, what do we think? Like if I have the set S, I mean any set A or S, then if you want to define a reflexive relation, you have to include all the same pair. Same pair is this type of pair. Okay. So if I just write so this type of pair such that A belongs to S, if I collect this set will be always a subset of R if R is a reflexive relation. That means all the pairs of same element will be always there in reflexive relation, but there can be other element, but at least this element should be there. Okay. Just for example, you have your A's as 1, 2, 3. So if you want to define reflexive relation, that means clearly all elements for all the elements 1, 2, 3, you should have that means the relation R should contain the pair of same element. That means 1, 1, 2, 2, and 3, 3. Right? So you just have to check whether these 3 elements are there or not. So in the relation defined here, you can find these 3 elements. That means you can directly conclude these as reflexive relation. Okay.
All the elements should be there, no, madam. If the S contains the F contains the cardinality is 3, then R should have the minimum that 3 pairs.
Yeah. So in the case of reflexive relation, all the elements AA such that A is in S should be there. So if suppose, for example, if I exclude this element, then whether you just tell me whether R is a reflexive relation or not right now.
No, ma'am.
No, right? So you just we want this property. That means this set should be a subset of the relation if the relation is reflexive. Okay.
Ma'am, if
So
only
extra elements doesn't matter, is it?
Mm-hmm.
Extra elements that are present, like for example, 2, 3, 3, 2, which are
extra
not
element doesn't matter.
reflexive.
Yeah. Extra element doesn't matter. That means there should be this 2 or 3 elements should be there, which I need, which we need, and there can be other elements which are not like in this form. So it is not our matter of concern. We just need to check whether this type of pairs for all the elements in the given set is there or not. Okay.
Reflexive relation, extra element is not mandatory, no?
No, it's not mandatory, but it can be there. So this is not a, problem.
Can you explain transitive property once again?
Yeah. Transitive I will explain. I am now just explaining reflexive property. So if you are okay with reflexive, I will move to symmetric and transitive.
Ma'am.
Okay. So symmetry means this is the typical definition. That means if you have AB in the set, then you have to check for BA.
Sorry to interrupt you, ma'am.
Yeah. No, it's fine. Yeah.
Ma'am, if only identity pair will be there, then it will be reflexive or not?
Yeah, then it will be reflexive. That means this element should be there. There can be other element, there cannot be other element, doesn't matter. We will just check whether these elements are there or not. Okay.
Okay, ma'am, thank you. You can go ahead.
Tablets are here, it is also reflexive.
Can you repeat again?
Ma'am, when doublet is a present in a relation, it is also reflexive, no?
Yeah. So in what is just mentioned, whenever you are trying to check a relation whether it is reflexive or not, you just need to check whether this set is subset of this set or not. Okay. So doesn't matter there are other elements or not. It doesn't matter. Okay. Is it fine for all of you?
Yes.
Yes, ma'am.
Okay. Yes. Okay. Then we can move to symmetric property. So what a symmetric property is, that means if AB is in the set, then BA should also be in the set R, right? So if we have AB, then we will only check for BA, right? If we don't have any AB, then we don't need to check for BA in the case of symmetry. Okay. So suppose you have the set 1, 1, 2, 2. Okay. This is the relation. So is it reflexive?
Yes.
No, ma'am, because 3, 3 is not present in it.
Yes, right.
No, ma'am.
All the element in this form, for all the element in the given set should be there. So because 3, 3 is not in the set, so this is not a reflexive relation. Okay. But is it symmetric?
Yes.
Yes, ma'am.
Yeah. Yes, ma'am, it is.
This is symmetric.
Symmetric.
Yes, ma'am, it is symmetric.
So if I add 1, 2 here, then?
No.
It is symmetric. No, ma'am.
Yeah. So in order to prove a relation symmetry or not, like if you want to discard the relation as not symmetric, then you have to pick an example. If you have any example, then you can conclude that the relation is not a symmetric relation. Okay. But if you don't have any example, that means for the first case, when we had 1, 1 and 2, 2 as the set, then that means just remove this. If I just remove this, so for this set, I don't have any example which can discard the definition of symmetric property, right? So in this type of cases, in this type of cases, we will call the relation as symmetric relation automatically. Okay. And same for transitivity. If you have AB and BC in the set R.
No. Ma'am, this is transitive.
1 comma 1 and 2 comma 2.
Yeah, this is transitive, right? This relation is transitive. So again, the concept of transitivity is also kind of same as symmetry. If you have any example such that a comma b and b comma c is in the set, but a comma c is not in the set, if you have this type of example, then only you can say the relation is not transitive, right? But in this example, we can clearly see that there is no element in that AB and BC pattern, right? So if you don't have any element in AB and BC pattern, then we need not to be bothered about AC. Okay. Suppose, just for example, if you have 1 comma 2 and 2 comma 1, suppose this is our relation. Is it transitive?
No.
No, ma'am.
No, ma'am.
No, ma'am.
Because
One
here,
comma 1 is
here we need 1 comma 1 because we have the pattern A comma B and B comma C, right? But for this example, we don't have the pattern for any element. So if you just union
Excuse me,
this
ma'am.
two
Hello.
set, yeah.
Ma'am, in this example,
Mhm.
1 2 is present and 1 1 is present. It is past transitivity test, no, ma'am?
No,
When
no,
1
no.
2 1 2 is present and 1 1 is present.
No, 1 1 is not in the test. Sorry, in the set. No, 1 2 and 2 1 is in the set.
But ma'am, we are consider 1 1 and 1 2. It's past transitivity test, no?
Either you're saying like
2 1 should be there.
see, this is the set.
Conditions. Two
1 2
conditions.
and 2 1. Okay.
For transitivity, madam, as I can recall,
No, ma'am. No,
condition, two conditions has to be satisfied. First condition is if A comma B is there, then there should be one B comma C.
Yeah, that
condition.
is the definition, right? If A comma B is there and if
Excuse
B
me,
comma
ma'am.
A is there, yeah.
And Rajmani has different doubt. He is
Ma'am,
thinking
please listen.
One by one, please. One by one.
Ma'am, when we take one example, 1 comma 2 and 1 1 also, then it's past transitivity test, no, ma'am?
Yeah.
Okay.
Yes. So you can take it as A and B, then it as B and C. So we need A and C. So our A and C is again 1 comma 2, which is in the, yeah, this is
when AB is present but BC is not present, it is past transitivity test. No,
yeah, it's passed. But for this example, you have AB and BC both. For this example, you don't have AB and BC. AB is there, but BC is not there. Okay.
Yeah. Yes. Hello.
Yeah.
Ma'am, if AB is present and BC is not present, then why it is still transitive?
Because what I said, you should have some example to discard the definition. If AB is there and BC is not there, then you will not get any example which can discard the definition of transitivity, right?
And if AB is present and AC is present, is it transitive?
A, B and AC. Yeah, in that case, it will be transitive because you just need this form, AB and BC. I mean, one pair, this B should be the second, in the second position of one pair, and the same B should be in the first position of one pair. Okay, so you should get this pattern. Then we only check for AC. Otherwise, not. Okay.
Okay, ma'am.
Yeah. So this is the first thing you have AC, so that you can check for. But if you are not getting anything like such pattern BC present in the set, so you just you need not to be bothered about AC. The set will be automatically transitive because you don't have any example which can discard. Like when you are
Sorry to
saying
interrupt.
a particular, yeah.
As you said here, A, B, and then B, C, then the order is like A and C. So the first order, like A will be the first and C will be the second. And if it is changed like CA, so is it not a transitive? transitive
Yeah, so
property.
you are saying A comma B and C comma A, right? C comma A.
Yes.
Yeah, then in that case, you should have C comma B in the set. C comma B in the set. Again, we have the pattern, right? One pair which is ending with A and one pair which is starting with A. So you just have to C comma B present in the set. So this is just a pattern. A, B, C are just a pattern.
And
Okay.
also it should be the same position, right? Like if A is at
Yeah.
first place and C is
Yes.
the second place, so it must be the same in transit,
Yes,
right?
right. Yeah, right. Yeah. So C comma B must be there, not B comma C. Okay. Okay. Is it fine for all of you?
Yes, ma'am.
Yes.
And the equivalence relation means we mean a relation with reflexive, symmetric, and transitive. Okay. We will check one by whether it is reflexive, symmetric, or transitive. If all the properties are satisfying, then we will call this as equivalence relation. Okay.
Excuse me, is it possible?
Yeah.
Can you please explain once again the reflexive property?
Yeah. So
Please.
reflexive property means this. I mean, or if the set, the mother set S as some element, the similar type of pair. That means the pair of same element should be there for all elements present in the given set. That means, for example, you have the set S 1, 2, 3, and you have the relation. So at least 1, 1, 2, 2, 3, 3 should be present in the set R. There can be other element, but at least these three elements should be present in the R. Only then we can say the relation R as a reflexive relation. Okay.
Ma'am, if there is like 2, 3 also, then also it's fine. If there is some extra element
Yeah.
like 3.
Yeah. If there is any extra element, then it also fine.
Suppose the element is 7, 8. Then
okay. No, I mean 7, 8 cannot be there. Then it will not be a relation even. Relation means it should be subset of S cross S, right? So 7, 8 is not present in S. So how can we include 7, 8 in the set, right?
And I believe also it should be 1, 3. Is it possible, like, ma'am?
Yeah.
As we not mentioned 1,
If
3.
you
no, sir. No, ma'am.
1,
Actually,
2
what
as
I
well.
was saying was not S cross S, but in general. Suppose if there is like a pair where like if there is a set where there it's a reflexive, we have to check it or not. So if there is 1, 1, 2, 2, 3, 3, and then there is 7, 8, then would it be a reflexive or not?
7, 8, I mean, it depends on the set. I mean,
For example, if you write a set, it has 1, 1, 2, 2.
okay, so first you have to take a set, okay, not a pair. First you have to take a set. So just let me let us specify the set. What is the set? Yes, you have to define relation on a set, right? For that you have to first specify a set. Then only you can define a relation. So relation is basically subset of this pair S cross S. So for that we need the set S first, right? Then only you can define a relation. Am I clear or you have any doubt?
Yes, clear. So as I said, is it possible that 1, 3 and 1, 2, is it possible it should be included in the reflexive property?
1, 3 and 1, 2.
In a reflexive
I will
property,
not say
doublets
in.
are important.
So what am I saying is in reflexive property, if you want to verify the reflexive property, only this type of pair, that means A, for all A belongs to the set should be in the relation. There can be other relation, that doesn't matter anyways. But this element should be in the relation. If your set is 1, 2, 3, and 4, then 1, 1, 2, 2, 3, 3, and 4, 4, these 4 elements should be there in the set.
Suppose, ma'am, there is no 4, 4, 1, 1
Then
is.
then it will not be reflexive. You
Okay.
have to
So for every element of S 1, 2, 3, 4,
yeah.
there has to be 1, 1, 2, 2, 3, 3. Every pair should be there. That has to be same.
Yeah. Every pair should be there.
Doublets
For
are present.
every element. Yeah. So for every element, the similar tuple should be present in the set. Okay, this is the condition. There can be other element, doesn't matter, but this is the least possible condition, that this 4 elements should be at least there.
Doublets are mandatory, but we can take other element as well.
Yeah. So that means if you have the set 1, 2, 3, 4, then these 4 elements are mandatory. But if you just add randomly some element, again it will be reflexive, because we have these 4 elements. But like this
Then
is
the
our
same
need.
property will goes for symmetric also if there is some extra element that doesn't matter.
Yeah, that doesn't matter. If you have this type of element AB, then
Yeah.
BA should be there. But if you don't have this type of AB type of element, then you need not to be bothered about it. There can be other element, but if you have AB, then you should have BA. And like just for suppose you have 1, 1 and 1, 2 and 2, 1. Okay. So in that case, you have AB as 1, 2, then you need BA. So BA we have, right? Again, another element we have 1, 1, but it is not in the form AB. So we need not to be bothered about this element. Okay.
And in this set, suppose there is 7, 1. 7, 1 also. So it will not have the symmetric property because.
No, 1, 7 should be there.
Okay.
Okay. Fine. All of you are okay with it?
Madam, all these properties will be considered only for single set, or if you have two sets and we take cross of that, like set
Yeah.
S1 is there,
So
S2
if you
is
have
there.
two set, I mean from A to B, it will be subset of A cross B.
So in that case, if 1, 1 is there and another 1, 1 is not there, then it is wrong. Remember, like A contains 1 and B also contains 1 in its set. So 1, 1 for that equivalently another B.
In that case, in that case, we will only check for the element which are in, for like possible element. I mean, which are in both A and B. Okay.
If it is there both, if the particular element is there in both set A and B.
Okay, just let us start with the example. And suppose you have your 1 and 2, okay, and B is suppose 2 and 3, okay. In that case, 1, 1 we cannot have in the set, right? Because relation is subset of A cross B. 1, 1, if I want 1, 1, that means 1 should be present in the set B, right? Correct?
Yes, madam. So you will have only 2, 2.
No, in that case, it will not hold. We need 1, 1, but 1, 1 cannot be in the set, right? Because 1, 1 is not in the set B. In that case also, it will not be a reflexive relation. I mean, we are bothered about this in set of all inputs here. Okay. Is it fine?
Madam, like in the example you are given A comma B, like A cross B will be, the pairs will be 1, 2 and 2, 3. That's all, no?
Yeah, you can define anything, but
in this
what it
particular
doesn't mean
example.
1, 1, we cannot take 1, 1 in any case, right? So
Correct,
1,
madam.
1 cannot be there in the relation for any case. So for any case, you cannot define any reflexive relation from this set A to B.
Reflexive.
Yeah.
Okay, we are talking about symmetry. Okay.
No, I was talking about reflexive. Like if you want to define a reflexive relation from A to B, this is not possible, because in that case you want like we need 1, 1, right? But 1, 1 is not in the set B, so 1, 1 will not be in the set R, right?
Okay.
Yeah. So this is like we cannot define any reflexive relation from A to B in that example. But we can define symmetric relations. No ways. Okay. So 1, like 1, 2 and 2, 1, we can define a relation in this way. No, oops, I'm sorry. This is not
It's
possible.
neither symmetry, it's neither reflexive.
No. If you just, yeah. So if you just take this element 2 comma 2, so it will be a symmetric relation, it will be a transitive relation too, right? But it is not a reflexive relation. Okay.
Yeah.
Right.
Okay, ma'am.
Yeah. Okay. Anything else? No, right? So we can move to the example.
Ma'am, the example that you gave, the set of A into B, this one, the last example you gave.
Yes.
So in this, you are saying that it cannot be symmetric and it can be
Like,
reflective.
no, it cannot be reflexive, because in order to be reflexive we want 1 1, right? In that case 1 should be present in the set B, right?
Yes, that I got it, but how it is symmetric and transitive
Like
both?
if I take 2 2, this is our relation, suppose, then it will
I
be
thought it's A cross B. I thought from that example it's A cross B.
no. A cross, like if you want to define a relation, it should be a subset of A cross B. It is a subset of A cross B. It can be anything.
Okay.
Yeah. So you can take 2 comma 2 also, but if you take A cross B, then it will not be reflexive, symmetric, and transitive.
Yes.
Yeah.
Okay.
Correct. Okay.
Ma'am, excuse me, ma'am. Ma'am, the example given for a reflexive property, it will come for equivalence property also, right?
Which example? This one.
Reflexive property, ma'am. Like the
This
example
one.
given in the slide.
Yeah. So this one, right?
Yes, ma'am. It will come for the equivalence relation also, right?
So that is you have to check all the relations. I mean all the properties. So we know this is a reflexive, right? So
Yes,
you
ma'am.
have to, yeah. Suppose you want to check the symmetry, then we need to check whether it is symmetry or not. So we will take the pair A comma B, right? So we can see there is only one element which is in the form A comma B, which is 2 comma 3, right? That means 3 comma 2 should be there and 3 comma 2 is there. That means it will be symmetric.
Okay.
And for transitivity also, you have to check whether there is any element in this form, A comma B and B comma C. So you can check that 2 comma 3 and 3 comma 2, A comma B and B comma C, right? In that case, we need 2 comma 2, which is present in the set, so no matter. Again, you can take this as oppositely, that means 3 comma 2 and 2 comma 3. That in that case, like 3 comma 2 and 2 comma 3, then you need 3 comma 3 present in the set, which is in the set. So it will be again transitive also, right?
Yes, ma'am.
So this relation, it will be equivalence relation. Okay.
Yes, ma'am. Thank you, ma'am.
Ma'am, can you explain anti-symmetric or asymmetric?
Madam, one small doubt in this, madam. Like 2 comma 3 and 3 comma 2 we are having. So to get this transitive property, 2 comma 2 is there. Is it necessary to check for 3 comma 2 and 2 comma 3 also?
Yes. Because order doesn't matter here, no. So you can take AB as 2 comma 3. You can take AB as 3 comma 2 also, right?
So if 3 comma 3 was not there in this set,
not be a
in this
transitive.
relation, then this is not reflexive. I mean, equivalent. Transitive. It is not transitive and it is not equivalence. 3 comma 3 it is removed.
Yes, correct. Yeah.
Okay, madam. Thank you.
Okay.
So
ma'am, please tell me one thing. Hello.
Ma'am,
Yes.
if it is 3 comma 3 is removed, it's not transitive.
Yeah, it's not transitive, because then we will get an example, right? Like 3 comma 2 and 2 comma 3 is there, but 3 comma 3 is not there. So with this example, we can just discard the definition.
Okay.
2
comma 3, 3 comma 2, and there has to be 3 comma 3 for that.
Yeah. You can change the order, right?
Okay. 3 comma 2, 2 comma 3, and then for transitive it has to be 3 comma 3.
Yeah. Similarly for 2 comma 2 also, like if 2 comma 2 was not there, in that case also it would not be a transitive relation. Okay. So in order to be transitive, you need both 3 comma 3 and 2 comma 3.
Okay, with
So
2
the
comma 3 and 3
anti
comma 2 as a pair.
Again, repeat once again.
like 2 comma 3 and 3 comma 2. For
Yeah.
that we need 3 comma 3 also and 2 comma 2 also.
Yes, yes. So like you can take it as 3 comma 2, 2 comma 3. This is one way. Also you can exchange their position. That means 3 comma 2 comma 3 and 3 comma 2. Okay.
Okay, so
And if
suppose
you exchange their position,
ma'am, suppose if there is 2 comma 3 and 3 comma 2 and 3 comma 3 is there but 2 comma 2 is not there.
then it
So
would not be a transitive.
so to be it transitive, if it has 2 comma 3 and 3 comma 2, then it has to be 3 comma 3 also and 2 comma 2 also, both.
Yeah, yeah, right.
There has to be
Because
both.
you can change the position. So position
Yes.
doesn't matter here, right? So you can change the
Okay.
position. And if you change the position, we need two different elements for two different
Yes.
positions.
Yes. So if it has 2 comma 3 and 3 comma 2, it there has to be 3 comma 3 and 2 comma 2 to make it transitive.
Yes, right. Yeah.
Ma'am, when A cross is present, that space order does not matter.
Yeah, here in any set, if it is not a ordered set, order doesn't matter here. Okay. So you can take like in any order so that the combination of A, B and B, C can be changed. Okay.
But ma'am, A cross B is present. That place order is important. No?
No, order
When
is not.
A cross B.
Okay, in a pair order is important. I mean, 2 comma 3 and 3 comma 2 is not the same element. In the pair order is important, but when you are getting the set R, so here order is not important. I mean, 2 comma 2 and 3 comma 2 you can take as like that. Also, you can exchange their position. I mean, 3 comma 2 and 2 comma 3. Are you getting my
Ma'am,
point?
please tell me, when A cross A is present,
Yeah.
that place of pair order is not also important, na? Order pair is not important.
No.
When A cross A present.
So in pair order is important. In pair you need order. But what I'm saying is
But ma'am, A cross A, when A cross A is present, that's I think order not important because the same set is
only
there.
A cross A. You're saying only A
Yeah.
cross A. That means only the same type of elements.
Yeah.
Yeah, in that case it's not mandatory. Yeah, in that case you don't need it. I mean, you will not get any example if you also change the order, right?
Okay, thank you, ma'am.
Yeah. Okay. So this is next example. So you have a given relation here and you just have to check whether it is symmetric or not. A hint is given here also. So just give you 3 minute time to solve it and let me know the answer. Okay.
Yes.
Okay. I got one answer is yes. Okay, let us wait for others too.
It is
Yes, ma'am.
symmetric.
Yes, ma'am, it is symmetric.
Yes, ma'am. Yes, ma'am.
Yes, ma'am, it's symmetric.
Yes, ma'am. Symmetric.
Okay. So, so what is our relation? A relation is like A comma B, where A and B lives in the same city. That means if so,
Chennai, same. No
yeah.
other thing.
So that means if I change by definition, if I take A comma B in the set, that means A and B live in the same city. So obviously B and A live in the same city. So it will automatically imply that B comma A will be in the same set, right? So it will be a symmetric relation. Yeah. So you're correct. This is the next thing. Yeah. It's just solve. Yeah, I'm just taking 2 minute time. I'm coming back after just 2 minutes. You just take your time to solve it. And after backing, I will
Okay,
just.
ma'am. Not a problem.
True.
True.
Let a relation R be 2.
True. True.
Because C is not there.
True, ma'am. True.
It is a transitive relation because if let's say two people A and B live in the same city, oh sorry, A and B belong to this set R, and B comma C belong to this set R, then A and C will by default belong to this set.
Madam, one small this thing, madam. Peer deck we are not using, madam.
No. We are not using pair deck. This is just a format. Yeah.
No, but previously we used to use the peer deck.
No. In maths one, we never use the pair deck. This is just a pattern for the slide. Okay, so you just avoid this. We are not using the pair deck.
Okay.
Ma'am, what we are not using?
The pair deck. This one. So this
What
is
is
just
that,
a
ma'am?
typical site. Okay. So.
Ma'am, what is that peer deck?
I guess what I know, it's a platform. You can give your answers and all in this platform. So
What is the name, ma'am? What is the name of that platform?
Peer deck. You can find the. So we will not use this. So for this class, you don't need the peer deck. Okay. So this is simply a site. Okay. Yeah. So we have the relation, and we have to check whether it is a transitive relation or not, right? So just recall our definition. Like if you want to check it transitive, that means we have to check whether if there is A comma B and B comma C in the set, then it should imply that A comma C in the set, right?
Yes.
So if you have to check transitivity, we will start with this and we will check whether we can imply this or not, right? So we will start with this. If I start with this, that means we will get A and B live in same city and B and C also lives in same city, right? That means A and C will be in the same city again, automatically, right? So A and C will be in the relation.
No, but here C itself is not there, no, madam, actually.
No, actually, like if you want to check transitivity, then you have to consider this first. That means A and B live in same city and B and C is also live in same city. Now
No,
it
that
is
condition is not given, no.
no.
But
We are
according to
checking for
condition, we can use
transitivity, right?
this.
No,
So
but transitivity, as we were telling, no, if A and B are there and B and C are there, then only we have to check whether A and C are there.
yeah.
Here A and B only is there. B and C is not there at all, no.
In that
So,
case, we need not to check, right? In
yeah,
that
that
case,
is the reason this is a transitive relation.
Ma'am, I guess it is being considered that this is the set is given in set comprehension notation, not in the explicit way.
The set itself is not given, only relation is given.
now look, your
Yes,
set
the
is
relation
the
is given,
city.
but
Your set is the city. Like, sorry, your set is the like people in the city.
Yeah, correct, madam. People in the city, but in relation only two people are considered. Third person is not considered at all.
No. See, this is not the like. This is not a set with one element. The thing is, this is just a representation. I mean, what it means is
That's a condition, no, ma'am. That's a
yeah,
condition.
that's a condition. Like A comma B is in the set R. That means A and B lives in the same city.
Element 1 and element 2 lives in the same city.
Yeah. So basically, this is not a singleton set. That means the relation R, if our set is collection of all people in the city, then this relation R is basically a pair of all possible peoples.
No, but I can say our set is consisting of people living in 10 cities.
Can you repeat?
I am defining, since set is not defined here, I am defining a set which is having people in 10 cities. Different, I mean, 2 cities maybe.
No. See, what we know that the relation is subset of, suppose our set is S, then this relation should be a subset of S cross S, right? So you are taking A, and what is A? A is member of some city. right?
Okay, madam, we'll agree to disagree because since the original set is not defined here, I am not able to comprehend how the relation has been made because it is not told anywhere. No, what is the set? Original
Okay,
set.
so
We should have a
by
set.
default, I mean, yeah, this is not mentioned here. They should mention it. This is,
Yeah.
yeah, your notes concern is correct. But the thing is, by default, we will understand that the set is basically like the collection of all people in this city. Okay.
Ma'am.
No,
That
one thing
means
I learned
that
from IIT
means
is you don't assume anything, madam. It has to be explicitly given.
Yeah, that is right. But for that case, we are assuming that.
No, how I am seeing this as in the transitive relation definition it is given, like if there is no C at all, then that becomes a transitive relation.
Yes.
So, I
Ma'am.
mean, the reasoning
See,
why I'm
the
telling
thing
true
is,
is
see, just listen to me. If there is no C in the set, then you just need not to check for transitivity. Like, if you want to like discard the transitivity, then you should have some example which is not following the definition. Okay, that is what I started with the definition. If you don't have A comma B and like C for some set, then we need not to be bothered. But if there is any C, then we have to check whether it is transitive or not. We are
Ma'am,
assuming the
here
worst
I
case
think
here.
okay, madam. Okay, no issues. Let us
ma'am,
proceed.
here I think BC means we have to replace the original definition here AB. We have to replace A to B and B to C. Means we have
Yes.
to construct for BC. That means B and C lives in the same city.
Yes, right. So that means if I take A and B, like if I follow the definition, so if I take A, B, and B comma C in the set, that means with if I follow the definition of the R, then it will mean that A and B live in the same city, and B and C also lives in the same city. So it will automatically imply that A and C also lives in the same city, right?
Yes, yes.
That's the point. Here we need not to be bothered about the set because like you just it is enough you just follow if you just follow the definition of the relation. The set is automatically the set of all people in the city. This is by default, right? That is what I wanted to say.
Hello,
Is it
ma'am.
Ma'am, I understood what you said, ma'am, but when I looked at the question, I understood everything. But then, like, when you look at the question, A and B lives in the same city. So, automatically, if the similar question arises, since C is not there, what my thought will be like, since C is not there, it is not a transitive, right? We need not check that. So like if it is a similar question, my mind like will not go like everybody are in the same city, so we'll consider C also as like that.
No. See, this is not the case. Uh, if C is not there, then C is not your point of concern. Okay, so you have to assume C is there because like if like after assuming this line like A, B and B, C is there, after assuming this thing, if you get the conclusion as AC may not be in the set, then we can conclude that this may not be a transitive. So here we are assuming that all like the condition is holding, that means AB and BC is there, and in a result we are finding that we're getting that if this happens, even if this happens, then it will imply that AC is in the set R. So if it is happening, if it is the case, then we will get the result as AC in the set. But if it is not the case, then we need not to be bothered. It will be automatically transitive.
Okay.
You're just
Hello, ma'am.
guessing, na, madam.
When you are solve the in this question for descriptive method, and that's an important condition to assume this condition A, B, B, C, and then AC. Without assuming
Yeah,
this
so
condition, you can't
no,
prove the transitive.
see. This is not about proving transitive. That the thing is, if you have this type of pair, then only you need AC. Otherwise, you don't even need AC, na. So you have to check whether it is satisfying or not. We are just going via the definition, nothing else, right?
Hello, hello.
Mm-hmm.
I'm audible.
Yeah.
Ma'am, how can I get the video lecture of yesterday discussion of math?
It's being live streaming in the YouTube channel, so you can go to the official YouTube channel. You will get the live stream.
I searched so many times, ma'am, in IITM BS degree program channel.
Yeah,
But
you just go to ITM BS degree channel, then go to live. Then in live you can find the video.
But video is not uploaded on YouTube of yesterday lecture of math.
No, it's being live streaming. It's not about uploading. So you just go to live, then you can find. Just go to live, okay?
Okay, ma'am.
After the lecture is over, I think it will be uploaded on YouTube.
No, it's being live streaming. You can find it on the YouTube channel now also.
It is live, madam. I checked.
Yeah, it's
Yes,
live.
it is live, and I think it will be also uploaded after it.
Yeah, it will be auto saved. Like it will be auto saved after ending the class.
Yes.
Mm-hmm.
Where I will get the link of this lecture and yesterday lecture?
Can you repeat again? Whatever.
Where I will get the
Link of the Friday lecture. I don't think you had any Friday lecture.
No, I am talking about yesterday, Saturday.
Yeah, so the thing is for TA talk, you should get a like Excel sheet, right? In the Excel sheet, you will get the link. And for instructor talk, you just go to the official channel and go to live. In live, you can find all the lectures.
Okay. Okay, but the video link of on YouTube of YouTube is not available in our calendar.
No, link I've sent actually.
In the link of yesterday's session, there was some other video for 9 hours 53 minutes is going on.
Okay.
It is not yesterday's session.
Okay, it's fine. Let's not delay with this thing more. So if you want the link, I will share the link in the chat box after the end of the class. Okay.
Okay.
Yeah. You can find it. No issue.
Ma'am.
So, yes.
Ma'am, in this question, if BC itself is not there, then the relation is transitively, right?
Yeah. If BC is not there, then the relation will be automatically transitive. So we are just checking if AB and BC is there, then what is the case?
Ma'am, here AB is here, BC is not here, and AC is not here. Why we are discussing so more of this topic?
So I just tell this is a general notation. That doesn't mean that only AB is there. This notation means that AB is there whenever AB lives in same city. So in a city, so many people are there, right? So in relation R, all the pair of them, like all the pair of those people will be there in the relation who lives in same city. Okay.
Yes, ma'am, it's clear now.
Okay.
Yes,
Yes.
Any other doubt? If you have, you can ask. No. So is it clear to all of you, or if you have doubt, you can ask. Still, I'm asking.
Ma'am, in the Google Meet, what did you said about that Google Sheet? The thing that.
Okay, so in the Google Meet, you used to have the TA sessions, right? So in that case, I guess you have a Excel sheet. In the Excel sheet, they used they used
Sir,
to
send the
have.
link. Sir, send the link, ma'am.
Ma'am, please continue. What did you said in the TS session? There is a link of Excel sheet.
Yeah. So in the Excel sheet, you can find the link of all the videos, all the classes.
Ma'am, where can we find that Excel sheet?
Ma'am. Sir, send the link, ma'am. Sir, also send the link.
It's on the Google calendar. There is a link of an Excel sheet in the TS session.
Yeah. You can find the link from the calendar.
Sorry to interrupt you, ma'am. As you said that there are a number of people in the city and that all are transitive. So the set will be infinite or will it be finite? Or there will be a limit of the set?
it depends on the, like, it will not be infinite, first of all, because the number of people lives in a city is not infinite, right? We can count like until it ends, right?
Yes, correct.
Yeah. So the number of people who lives in Chennai, we can count ultimately. It can be a very large number, but we can count it, right? So infinity is something what we cannot count up to the end.
So the set will be finite, am I correct?
Yeah, this set will be finite. Yeah, we can count the set.
Got
It can be, I think, it can be the capital A, it has some domain, and capital B, it has some domain. That domain, the whole domain can be the possibility of A cross B. That means the relation.
Yeah, I mean, the domain of A and B, that means the set from where we are collecting A and B, right? So A and B is basically collection, like the set is collection of all peoples. Okay. So suppose we are collecting all the peoples all over the world. Okay. This is our set. We have all the peoples all over the world. Okay.
Ma'am, let me correct if I'm wrong, ma'am. Can I say?
Yeah,
Let me
yeah.
correct it. I think we should solve like that questions like that. Lives in the same city is a common, and we should change the position only A and B. In the place of A and B, we can write V and C, and then A and C.
Yes, obviously, because A and B is not exactly the member of R. It is just a representation, right?
Yes,
That
ma'am.
means it means that if A and B is in the set, that means A and B lives in the same city.
So in
Okay,
between,
that
we can
means
write V and C.
suppose you have some Rahul, Priya, and Ashok. Suppose, for example, okay. So Rahul lives in Chennai, Priya lives in Hyderabad, and Ashok lives in Hyderabad. Okay. In that case, Rahul and Priya will not be in the set because they don't live in the same place. But Priya, and Ashok will be in the set because both of them live in the city Hyderabad, right? That is what the relation means. Okay.
Right, ma'am. Understood.
Yeah. So suppose you have the collection of all people, just for like to illustrate it. Suppose you have the set as collection of all the people all over the India. Okay. So there are so many.
Are you discuss function part today?
Yeah, I will discuss. Yes. Okay, so suppose you have all the collection of people who lives in India. Now you have the relation, right? That means you will take all the people will be related who are in the set A. That means who lives in just for say, who lives in the city Chennai. So all the people who lives in the city Chennai will be related to each other, right? Right?
Yes, ma'am.
Yeah,
Right, ma'am.
but if you take one people who lives in Kolkata and one people who lives in Chennai, then their pair, if you make a pair with these two people, that pair will not be in the set. Okay.
Yes,
so,
ma'am.
yeah, because in this example, we are checking the definition. So we are assuming, we are taking the first step. If there are three such people, such that A and B lives in the same city, Chennai, suppose, and B and C also lives in the same city, Chennai, then obviously A and C will be also a resident of the same city, right? So that is what it was our concern. Okay, if there was a possibility that AC may not be in the same city, then we could have conclude that the relation is may not be a transitive relation. But in any case, we can always conclude that AC will be in the set. So we can conclude that the relation will be transitive.
Yes, ma'am.
Right,
Clear.
ma'am.
Okay.
And this will also reflexive, ma'am.
Yeah, this is reflexive. This is always reflexive. Like because set will be obviously people will be in the same city with his self or herself, right?
Just when the same person can be mapped to himself or herself.
Yeah. So it's obviously right. One
Yes,
people
ma'am.
cannot live in two different city at the same time. So it
Yes.
is obviously reflexive, symmetric and transitive. Okay. Okay. So is it clear to all of you? If you
Yes,
have
ma'am.
still any doubt, you can ask.
Clear, ma'am.
Okay. Okay. Fine.
All
Clear,
clear,
ma'am.
ma'am.
Okay. Yeah. So this was the last question from our relations. Now we have to move to functions. Okay. So I will first define and describe you what a function is. So if one line, suppose we have two set A and B. Okay. So first it's about the notation. We note a function f from A to B. Okay. You can denote it with G, F, G, H, anything. But for say in general, we will define as function. Okay. F for function. Okay. Okay. So function is nothing but a particular type of relation with some extra condition. Okay. So we have to be bothered about the condition, what the condition is. The condition is basically for each element in the domain. That means for each element in the A. So if I just let me write the definition for element in A, there will be a unique image in the set B. Okay. Okay. So this is the definition of function. That means if you have a relation with this condition, okay, relation plus this condition, then we can conclude that this is a function. Okay. Now in this condition, two word is most important. The first thing is each element in A. Okay. And the second thing is a unique image of B. Okay. So here, if you want to define a function, the first element, the first set, that means the set of all input, basically called as a domain. Okay. This is domain and this is called as codomain. Okay. Now, from now, I will use the term domain and codomain. Okay. So the first thing is each element in A. That means for any element in A, you have to assign that element with a image with the output in the set B. Okay. And it should be unique. That means for one input, you cannot pair it with two different output. Okay. So let us start with the example. If I take A equals, suppose 1, 2, 3. Okay. And suppose our B is same 1, 2, 3. Okay. So the first relation I am defining as 1, 1, 2, 2. Okay. The thing is, it is a relation, right? Because it is a subset of A, B. We know that it is a relation. We don't have any problems.
Yes, ma'am.
Yeah. But is it a function?
Yes, ma'am. It is a function. I guess. No, ma'am. No, ma'am. Because
No, 3,
Each
3 is not.
element, all the elements of A should have a image in B, I mean, in the relation. So 3, 3 is not there, hence it is not a relation.
Like not 3, 3, we can have 3, 1, 3, 2, anything. But there should be an image for 3. Like 3 should be there in the first position of some pair, right? So that means, remove this one. So this is a element, this is a relation, but not a function, right? This is a relation but not a function. And the reason is, I will write the reason. And the reason is 3 doesn't have any image here, right?
Yes, ma'am. 3 doesn't have any image in B.
Yeah. So this is the first case. This is a yeah.
Ma'am, when any pair of A cross B present in a relation, it is a relation. But converse, it is not a two in the case of function.
Yeah, right. So function means you need this extra condition along with relation. I mean, this should be a relation. First of all, this should be a relation. Secondly, this should follow this particular condition. Okay. If it is not following the condition, just for example, for this example, we can see this condition, each element in A. That means we have an element in A which doesn't have any any image in the set B, right? That means this relation is not satisfying this condition. So we will conclude that this relation is not a function. Okay. If I take a second example, suppose 1, 2, 1, 3, 2, 2, 3, 1. Okay. So it is a relation, that is clear, right? But is it a function?
This that unique condition, it is not satisfying because one is
ma'am.
having 2, but again one is also having 3.
Right.
So it is not unique.
No, it is
Ma'am,
not a
any
function,
function
ma'am.
can be produce only one output.
Yeah. Okay. Right. Very good. So you are correct. For the element 1, we have 2 different images, which is not possible, right? For one element, we should have only one image. But we can see in this example, for the element 1, we have 2 different images. So one element cannot go to 2 different places at the same time, right? One person cannot go to 2 different places at the same time. So this is not a function, right? This is not a function. And the reason is
Different input produce different output.
yeah. For 1, we have 2 different images, 2 and 3. Okay.
2 and 3. For element 1, we have 2 images.
Ma'am, I didn't get this. Because 1 and 2, 1 and 3, both the images are there, 2 and 3.
Yeah. So see, for 1, we have 2 as an image because we are getting this 2 pairs. Like 1, 2 is a pair. That means we have 2 as an image of 1, right? Again, 1, 3 is a part of the relation. That means we are getting 3 as the image of 1. So this will not satisfy this unique image. So image is not unique here, right? For the element 1, we have 2 different images, 2 and 3, right? So this is not satisfying the second condition, that unique image. That is why we can discard it. Okay.
Ma'am, what do you mean by unique image?
Unique image means one input can have, that means one element from the domain can have only one image.
Okay.
Once you are pairing 1, 2 and 1, that means you are assigning 2 output with 1. That means 1 is having 2 different images, which is not possible in function. Okay.
Ma'am, 2 different input produce same output.
Yeah. Like 2 different input can have same output. In that case, we have different type of thing. That means this function will be a many to one function, but this will be a function. That means this is possible. Like for example, agar just wait. Let me just change the color. Okay. So if the third example is R 1, 2, 2, 1, and 3, 1. Yes.
Ma'am, when every element in a domain mapped in a codomain, but one remaining element in a codomain is not mapped, it is a function or not?
Okay, so for if there is some element in the codomain which is not having any pre-image, then it will be a function, but it will not be onto function. I am coming to onto and one function later, but let us first understand what a function is. Okay.
Ma'am, are you trying to say that an image can't have 2 pre-images?
No, a image can have two p images, but a element, that means the input, cannot have two images. So this is a function, right? This is a function because it is satisfying the condition. So here you can see that we have two elements, 2 and 3, having the same image. But this is possible if you want to define a function, but it will be a many to one function. Okay. Okay.
Ma'am, condition of a function की every element of a codomain is mapped. Every element in a domain is mapped with codomain. That's a mandatory condition.
Yeah, with it should be mapped with a unique element in the code.
Unique element. Okay.
Yeah. So this is another example. If I check it with the Venn diagram, okay, let me use my.
So, ma'am, to be a function, every input should have a unique output.
Yeah, right. Every input, like each input should have a unique output. So suppose we have all these pictures. Okay, suppose this is our A and this is our D. Okay, so same, we have A and B as 1, 2, 3. Okay, we are just drawing this picture. Suppose. Okay, so suppose this is our three elements, 1, 2, and 3. Okay, so this is our first case. We are mapping 1 to 1 this. So this is it a function?
No, ma'am.
No, ma'am.
Reason?
No, ma'am.
Not a
One
Because
has
single input,
by
we
one
can
and by
get
two
two
as
different output.
One by one. Wait. So the reason, first reason is?
One input produce two
Different output.
Okay, one input has two different output. And the second reason, is there anything else?
One input can be not produce any output.
This is the only reason, I guess. It is like, ma'am, if we take two different elements from
Ma'am,
B,
there is no
we have the
input for one
same
variable,
image in
ma'am.
A. Oh, this is also, it is not imaged.
Yeah. So
or
there
mapped to
is
anyone.
there is one input.
That has no image in B.
Yeah, right.
codomain.
Yeah, or the codomain.
In set B or the codomain, right? So these are the two reasons. Because of these two reasons, this example is not of a function. Okay. Suppose we have the second thing. Again, the same A and B. Okay. This is our second case. Okay. Is it a function?
Yes, ma'am, it is a function.
Yes.
Yes, ma'am.
It is satisfying the definition, right?
Yes, ma'am, it is a
Yes, ma'am,
function.
it is a function.
Yes, ma'am, function.
Ma'am, in the earlier slide where you mentioned two conditions for the function, the first condition was not mentioned, right? Every element should have a relation in A, and the in codomain it should be mapped with only
one unique element. Yeah.
But the first condition is not there. No, why?
Each element in A. And
Each
should
element in
map
A?
to a unique image. These two conditions are there. Okay.
So a unique image in the sense, I thought other
Only
elements
one. No. This is what like we mean that by the word unique image, we mean that one input can have only one image. One input cannot have two or three different images. Okay, like more than one different images. Okay.
So the same output can be the image of another input.
Yeah. So this is the case of the second example, right? The same output here. This is having two different pre-images, right?
For different input, we can get one single output.
Yeah. So the thing is, for one input, you have to get a single output, right? But for one output, you can have two or three different inputs. Okay.
Yes, ma'am.
They just
So
mentioned.
it means two person can go in same place.
Yeah. Right. So basically, one input can be associated to only one output. Okay, this is first note. The second note is, but one output, that means one element from the set B or the codomain, can be associated.
Can get this PDF?
Yeah, I will share. With more than one input. Okay.
Yes, ma'am.
So this note, okay, you have to keep this thing in your mind. So this is the function. This is a function, and this is called many to one function. Okay. Now I am coming to okay. Let me just first realize that whether you are comfortable with the definition of function or not. So this is definition of function, relation with that extra condition, and the extra condition is this. What does it? Like that means every element, each element from your input should have a a unique image in the codomain or in the set of all output. Okay, so all of you are comfortable with the definition of function?
Yes,
If you
ma'am.
have any doubt?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. Very nice.
Yes, ma'am.
Okay. So once we are comfortable with function, then we have to go to the next step. Like function can be of two different types, on one and on two. Okay. We have types in function. One.
Ma'am, if you don't mind, can you please again remind the definition of function?
Mhm.
In little bit, it is unclear to me. Almost like unique image is confusing.
Okay. So let me write the definition of function properly. A relation f from A to B is said to be a function if now the condition. If,
What we have seen is basically some basic data types. Basic data
Uh,
types were Boolean, which had true and false values, integers, which had negative, zero, or positive values, and the character data type. And we saw subtypes of this, various subtypes of this. And then we made this data type called strings, which was a sequence of characters.
can you be little louder? Actually, I cannot hear you properly. Maybe. Can you be little louder?
Yes, ma'am.
Okay. So let us just consider okay, move on with the definition. So if now the condition, each element assigned to so this word, each element and the unique element, this is our important keywords. Okay.
Okay.
Is the definition
Okay.
clear now?
Yes, ma'am.
Okay, fine. So this was our function. Okay. Now we have one and onto function. So we know that if we have a function, then can you mute yourself? Someone is. Okay, so yeah, if you have a function, then this case is allowed, right? That means two different input can go to one single output, right?
These
No,
functions are
ma'am.
clear on two, and those you explain by diagram, those are
Yeah,
clear.
that is what I am explaining. Okay, so this is a function, but this is not a onto function. Sorry, not a one function. So one function means we like, if you want to define a one function, that means we will restrict the okay. So we will restrict the second condition. That means one image can have only one pre-image. Okay. So if I write it mathematically, one function, if I write the definition mathematically, that means if x1 not equals to x2 in the domain, that will imply f of x1 not equals to f of x2 in the codomain. Okay. So that means if the that means one image in the codomain cannot have two different pre-images in the domain. Okay. That means if you have a one function, you will get a clear picture like that. All the element in the input, in the set of all input should be connected with the unique element for to being a function, and like any two element in the set of all input cannot have a same output. Okay. Okay.
Yes, ma'am.
Okay, ma'am.
Okay. So the definition of one function is clear to all of you?
Yes, ma'am.
Yes,
Ma'am,
ma'am.
please
Yes,
repeat
ma'am.
again.
Okay. So one functions mean basically any two different element from the set of all input cannot have the same image. Okay.
Okay, ma'am.
If I just route, that means this definition means any two different
Take some examples for one
yeah,
function.
sure. From any two different element from the set of all input cannot have the same image. Okay.
Ma'am, two different input can be produced same output in one function.
No, that is what I am saying.
Okay.
Different input cannot be assigned to the same output. Okay.
Two different input cannot assign a same output.
Yeah.
Okay.
So for example, first of all, this is an example of one function. Okay, this is a one function pictorially.
Ma'am, in command, you write the four elements, but four elements have a no, means fourth element have a no pre-image.
Yeah. So this is not a problem. Like every element in the codomain, like it's not like supposed to have a pre-image in the domain. There can be some element in the codomain which doesn't have any pre-image.
So this will not be an onto function.
Yeah, this will not be a onto function. So if I collect this set, that means collection of all pre-images, then this set called the range set, right? Or the image set.
Onto function is also called subjective function.
Yeah, onto function is also called surjective function. Yeah, and one function is called function.
Injective.
Okay.
Ma'am, if element in A does not have image, then is it one function?
Okay, if a element in A doesn't have image, in that case it will not be a function. Each
Yes, ma'am. It won't be a function.
Function, right? Each element from the set of all inputs should have a image. If you have any examples such that there is an element in the set of all input or the domain which is not having any image or output, then you can directly conclude that this is not even a function. Okay. Okay.
Yes, ma'am.
Yes, thank you.
Yeah. So for example, if you have AB as 1, 2, 3, suppose we want to define a function from A to B. Okay. Suppose our function is like okay. So first of all, this example a function? Is it a function?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
It
ma'am.
is a function, but not it is a one-to function.
A one function, right?
Yes.
A function. Yeah. Okay. So this is a function. Yeah. Yes. Someone is saying to something.
And it is a function, but it is not one function.
Yeah. It is neither one. Okay.
Okay, ma'am.
So it is not 1, not 1, as we have the same image for the
1 and 2.
right? As
Yes,
1
ma'am. 1 and 2 has the same image. Have the same image.
has the same
Image of 2,
image 2, right? And why it is not on 2?
Because ma'am, 3 has no pre-image in the domain.
Yeah, right. Because 3. So in order to be onto, we need that every element in the codomain should have a pre-image. Okay.
Yes, ma'am.
Onto or surjective function.
Please take one example for one function and solve its algebraic method.
Yeah, I will take. Wait. I will take
Hello.
all possible examples. Don't worry. Yeah.
What you have written here is that 3 has no pre-image. That means 3 does not have an X pair. Like 3 is a Y, but 3.
Yeah. Right. So that means if you have A, if you have B, and if you have a function from A to B, first of all, okay. So suppose we have this elements, okay. And the f function is defined in this way, okay. Suppose this is our 1, 2, 3. Okay, so this is called domain. This is our codomain, and one is called, this element 1 is pre-image of the element 1 here, okay. Pre-image of 1, and this element 1 is image of 1, okay.
Yes, ma'am.
Yeah. So if I say some function as onto function, that means all the element in the codomain should have a
Pre-image in the domain.
Yeah. Okay. So this is the definition for onto function. Okay. So if, for example, suppose we have a example function from the set of all real line to the set of all real line. Okay. As f of x equals to x square. Okay. This is our function. Okay. So is it onto?
No, ma'am, it is not onto because like -4 has
How you have defined
no
that function?
pre-image.
Real to real.
Yeah, real line to real line.
Because the negative reals will not have
Negative
pre-images
reals
in.
will not have any images, right?
Yes, ma'am, any pre.
Okay. So is it 1, 1?
No, ma'am.
No, ma'am, it is not 1,
It is
1
not one.
either.
Why?
Because
Because
condition input produce same
it is
output.
like 2 and
One-
-2 will have the same.
2 and -2 are
Ma'am,
not
because
same.
every negative function will have the positive image.
Yeah.
So
Right. So for example, if I take just some random number, so 2 and -2 are not the same, but their images are same, right?
Yes, ma'am.
Yes, ma'am.
Okay. So this is the type as we can check whether a function is 1, 1 or onto or not. Okay. Second thing, two different tests, vertical line test and one
How
is
is it
horizontal.
not onto? Can you please explain again?
Ma'am,
Yeah,
onto function.
because
can you
negative.
explain again?
Uh-huh.
Function can be repeat
Okay.
again.
Yeah, sure. So onto function means basically all the element in the codomain should have a pre-image. That means there should be an element in the set of all input which is assigned to that image. Okay. Or in simple word, we can say that if range set is equals to codomain.
और ये जो तुमको दिख रहा है ना कप टाइप का कप वाला तो बहुत मिल रहा था हम नहीं लिए
What?
Please mute yourself, somebody.
There is one thing I wanted to say that please say that to the team of IIT Madras also. So what happened?
For some time.
Yes, ma'am. So, ma'am, when the TA session is there for the math, the person who takes it sometimes not able to explain properly. So please, it's basically a teaching assistant, the person who takes for mathematics. Sometimes he's not able to explain properly. So please,
Okay.
with this advice to the team of IIT Madras also.
Okay, what?
Ma'am, did you listen to me?
Okay.
So basically, what I will suggest that you will have a instructor session for all that means summary and for any doubt type of thing. So you just try to clear your doubt in the instructor session. But if you are left with some doubt, that doubt you can ask to the TA session. Okay, so yeah.
Can you tell me any group of any official WhatsApp group of to
No,
interact?
so we don't have any official WhatsApp group, but if you want, you guys can create an official WhatsApp group.
Please, ma'am, please.
A lot of groups like that created by seniors, so it can be very helpful. You can check your
Yeah.
email. We can come back to the questions, ma'am.
No.
Yeah.
I can say for create for our batchmates to interact some topic and questions.
Yeah, so if you want unofficially, you can create your own WhatsApp group so that you can discuss. Also, you have discourse, you can put your doubts in the discourse. So we will pick your doubt. Okay, but let's not discuss this thing here. We have so many things to cover.
It's already given in chat box.
Yeah. So you have the link given in chat box, maybe the WhatsApp link, right? So you can check this. Okay, let's not delay. Let's come back to the question. So this was the first example. F of x equals to x square. This was a function, but this is not a onto, neither a onto nor a 1. Yeah. So now we have two different tests. One is vertical line test and one is horizontal line test. Okay. So vertical line test says basically says if you have a graph of a function, that means if once you have a function, you can draw a graph of a function. Okay. So if you have a function like that, okay, and if you
Ma'am,
draw
sorry to interrupt you. Hello, ma'am.
Yes.
In onto function, we can say every codomain should have different pre-image.
Not every codomain, every element in the codomain
Every
have
element, sorry.
at least one pre-image.
Ma'am, can you tell me any method to finding a range? Many questions are present in a practice assessment and credit assignment in regards to range.
Okay. Yeah, there is no naming method, but you can use some intuition. I will discuss them with you. Okay. I will discuss those intuitions. Okay. So that you can find the range. I will pick
Ma'am,
some
that function x square which you have written here,
yeah.
that -2 has the pre-image is 4.
No. -2 doesn't have any pre-image. -2 doesn't have any pre-image. Once you are mentioning pre-image, that means that -2 should be in the set range, in the range set of the function. But we are taking x square, right? That means no negative number will be there in the range set, right?
Okay.
So -2 is not even no negative mention, no negative reals has any pre-image. That means no negative reals will be present in the range. Okay.
If how can -2 be a codomain? Why it is considered as codomain actually?
In the set of all codomain, you can have extra element, but if you don't have pre-image for that element, that means it cannot be in the range. Okay.
Madam, what I am trying to understand is this function f is 1R to 1R, no? Like all the entire reals we are taking as domain.
Yeah.
Okay. And
Our
range
domain is real number, and here we are taking our codomain as set of all real number. Okay.
Yeah.
But
generally any function, the range, I mean, domain and codomain will already be defined.
Yeah. Yes, like if the question is about the defining domain and codomain, then you will get some definition for the function, and based on the definition you have to check that domain and codomain. So domain means basically at each point of the domain your concern should be finding the point where the function can be defined, right? Just for example, if I take the function as 1 by x, right? So we can easily check that except at the point 0, we can define the function anywhere else, right?
Yes, ma'am.
Yes, madam.
So the domain will be automatically real line minus the point 0. Okay. And the range you can also find. So for range, you have to check the functional value at the boundary points. Okay. So boundary points means I can this as this, right? So you have to check.
X is the function. 1 upon x is the function, ma'am.
Yeah. Our function is 1 upon x, okay? And domain is r minus 0, right? So r minus 0 we can rewrite as minus infinity to 0, here 0 to infinity, because we are excluding the point 0, right? So if you want to find the range, so you will check at the boundary points, okay? When x is tending to 0, That means when x is some point which is near to 0, then our function will be tending to infinity, right? If from the positive side, then positive infinity. If from the negative side, then negative infinity. Because if I just draw the graph of the function look like that, right? So when the domain, so if I draw the graph, the x-axis typically represent the domain and the y-axis typically represent the codomain. Okay. So you have a point in the domain. Okay. So once we collect, so this point 0 has no image, right? So that is why we just exclude the point 0 from the domain. Now, if I just want to check the range, we can check the range. That means our y-axis, right? This is the codomain. So check the range.
So range will be same as codomain. So it is onto.
Yeah. Yeah. No. So that is matter. Like if you take the codomain as R, then it will not be onto. Okay. But if you take the codomain as R minus 0, then it will be onto. Okay.
Hello, ma'am.
Yeah.
Ma'am, could you please say about this function whether it is injective or not? That under root x plus 2 by x square minus 9.
X plus 2 by
X square minus 9. Ma'am, how should I get to know whether this function is injective or not?
Okay. So for checking a function is injective, you have to go via the mathematical definition. Okay. So the mathematical definition is if x1 is not equals to x2, it will imply that f of x1 is not equals to f of x2. This is the mathematical definition, right?
Yes.
But we can also rewrite it contrapositively. Contrapositively, we can rewrite as if images are same, f of x1 is f of x2, then it will automatically imply that x1 is equals to x2. Okay. This is also you can consider as the definition. Okay. So this is the definition. Now we will follow the definition. So we will start with this condition. F of x1 is equals to f of x2. Okay. And our aim is to, if the function is 1, 1, then we can prove that x1 is equals to x2. Okay. So in the second line, we can write as x1 plus 2 x square minus 9 equals x2
From here,
plus
the x1 square, no? Yeah.
yeah. Okay.
Mm-hmm.
Then if the function is 1, 1, then you can somehow manage the equation, and in the final line, you can prove x1 is equals to x2. But what my intuition is, maybe function is not a 1, 1 function. So
Yes.
we can, yeah, because we have a square and root. So basically, if you have some even power, typically you can use your intuition and calculate that the function is like compute that if it's about the domain, like it's not necessary, but if the domain is real number and the power is even, you can use your intuition to like prove it not 1, 1. Okay. So what we will do, we will try to find some example which can just discard the definition, right? So do you have any example in your mind?
Any number, ma'am?
Any number means?
I'm not
Ma'am,
getting
plus
it.
1 and minus 1.
Plus 1 and minus. Okay, so I don't think this will be true, because so plus 1 means you will
I
get
guess the addition only works when there is only like there is an even power only, because it has an even power and it also has an
odd power.
so in that case we have to be a little
Yeah, right. Yeah. So we have to check whether we
Ma'am,
can.
this function is not 1, 1, ma'am.
Yeah. So if it is not one, find some example. But if there is no example, we have to prove whether it is 1, 1 or not. So once you are saying it is not 1, 1, then you should have some example so that the numbers are that is the inputs are not same but outputs is same. So do you have any example?
The example itself will work now, madam. Like root 3 under -9, and this will be 1 by 9. 1 by -9. So it is not equal, no? X1 is not equal to X2.
Once again, can you repeat?
No, yeah, once you solve this itself is not equal. Root 3 by -9 is not equal to root 1 by -9.
Yeah, this is not right. This is not equal. This is not an example. We cannot take this example. So maybe it may be a 1, 1 function. So in that case, we have to prove it. Like if it is a 1, 1 function, we have this equation and we have to use this equation. Okay. So let us try let us see whether we can prove it or not. Okay. So we have this. Then we have x2 plus x1 square minus 9. Okay. So what is the next step? In the next step, we can take a square both sides, right? So we will get x1 plus 2, x2 square minus 9 whole square equals x2 plus 2. Right? In the next step, we can break the functions. If I just break, so what we will get? Any one of you? A minus b whole square formula, right?
A square plus b square minus 2ab.
This one, right?
81, yes.
x2 plus 2, then x1 to the power 4 minus 18 x1.
What, ma'am, how did you remove the root?
By squaring both sides.
I just squared both the sides. Okay. Okay. Then in the next step we can multiply, right? Okay. Okay, let us just avoid the multiplication step. Let us see whether can we just exclude some term that 2 into 81 can be excluded from both the side, right?
Yes, ma'am.
x1, x2 to the power and
36 x2 square minus 36 x2 square minus
no.
26.
Let us just do it with one element first. So we will take x1 first, okay? So 15 x2 square x1 plus 81 x1. Then 2 into this. So we will get 2 x2 to the power 4 minus 36 x2 square. That's it, right? 81 into 2 will be cancelled out, right? This, yeah. Okay. So if I just multiply this 2, then we will get x1 to the power 4 x2 minus 18 x1 square x2 plus 1 x1 x2. So then again if I take 2, then 2 x1 power 4 minus 36 x1 square equals, okay? So that's the multiplication, right? Is it fine?
Yes, ma'am.
Is there any mistake? Is there any mistake? No, right?
No.
Okay. Okay, then we can take all the elements in the same side of the equation. Okay, so we will get x1, x2 to the power 4. Then we can take this element minus x1 to the power 4, x2. Like I'm trying to find the similarities. Okay, then we can take these two elements. So minus 18 x2 square x1 plus 18 x1 square x2. Then we can take these two elements plus 81 x1 minus 81 x2. Then we can take these two elements plus 2 x2 to the power 4 minus 2 x1 to the power 4. Then we can take this two element minus 36 x2 square minus 36 x1 square equals to 0. Right? Then in the next step, we can
Ma'am,
take
plus 36
ma'am,
x1 square.
Ma'am, when
Ma'am,
when
it's
you
plus
multiply
30 over 6.
Ma'am, 81 multiplied by 2, 162. It will also be.
yeah. So
there.
from the both side, it can be cancelled out, right?
Yes.
Ma'am, what about x1 multiplied by 18 x2 square?
Ma'am, 81 multiplied by 2.
This one, right?
They
This
cancel.
one. Okay. So if from this two pair, we can take x1, x2 as common. So we will get x2 cube minus x1 cube. Then from this two pair, we can take minus 18 x1, x2. Then again, we will get x2 minus x1 plus 81. This two will get, okay, minus 81. Then we will get x2 minus x again. From this two, if I take minus 2 common, we will get x1 power, okay, plus 2. Let us take plus 2. 4 minus
Ma'am, one
x1
thing
to the.
when you multiplied it.
What?
Ma'am, when you multiplied it, there was one term.
Which one? Which one? 2 into 81.
It cancel both sides.
This we can cancel from both the side, right? That is what I didn't. Is it fine? Up to now, is it fine?
Yes, ma'am.
Okay. Okay.
Yeah, go ahead, man. Go ahead.
So if you just check, we can rewrite this as x2 minus x1 and x2 plus x1, right? And also we can rewrite these as x2 minus x1 with some other cubic equation. I don't remember the equation, some cubic. Right?
Yes, ma'am.
Yeah. Then we can take x2 minus x1 as common, right?
Yes, ma'am.
And the like left out things will be there, right? Equals zero. From there, we can conclude x2 minus x1 equals to 0, or this will be equals to 0. From here, we can conclude x2 is equals to x1. Okay?
Ma'am, in that, ma'am, when you said that x2 की power 4 minus x1 की power 4, from that, how are you so sure that there will be a common x2 minus x1?
Okay,
There can
so
be square minus x1 square.
no. Okay, so see, you can write it as x1 x2 square minus x1 square into x2 square plus x1 square. Then you can rewrite this as x2 minus x1, right? Is it
You are
fine?
talking of that, na? x2 की power 4 minus x1 की power 4. From that.
Huh? But you can rewrite it in this form, na? You just take square of square, then break it in the square formula.
Yes, but you were taking the common was x2 minus x1. So I thought, how you are so sure that that will be a common x2 minus x1?
Yeah, so if I just break like x2 square minus x2 to the, this is our equation, right?
Yes.
x2 to the power 4. So we can rewrite in this form. Then we can again break it and we will get x2 minus x1, then x2 plus x1,
Okay.
then x2 square plus x2 square.
Yes, ma'am. Yes, ma'am. That step actually, yeah.
Okay,
Okay, ma'am.
this is the reason of this. Okay, so then in the last step we will get x2 is equals to x1, and here we will get another equation. Okay, now you have to conclude that the another equation will not be equals to 0, and that is your homework. You have to do. Okay.
According to your intuition, is it a 1-1 function or not?
Yeah, it should be a 1-1 function. According to intuition, it should be a 1-1 function. So this is your homework. Check this portion. This is not 0. Okay.
Coming to the last question, what you have solved.
I will screenshot it.
The
What?
one
Just show me the last step and I will screenshot it.
I will share the PDF. Don't worry.
Okay.
about the last question that we were solving, 1 upon x.
Yeah.
So in
Okay,
that,
just let me first. This question is clear, na? This is the typical step what we will use to solve, like conclude whether a function is 1-1 or not. Okay. So if the steps are
Can we take the square roots and do this? It will be very useful. The roots.
can you
What I'm saying is, can we take this roots and solve this so it will be easy?
yeah, you can do it.
Ma'am, we can solve the function by equalizing it to 0 such that means under root x plus 2 by x square minus 9 equals to 0. And if there's more than one value, then it is not injective. And if there's only one value, then it will be injective.
You can also use another methods, but what is the thing? You have to follow the definition mainly. Either the first definition or the second definition. Okay.
Okay. Okay.
Yeah. Okay. Yeah.
about the last question, what you have written there, is it like when the x is approaching to 0, it will be f to infinity, x to minus 0, it would be minus infinity.
Yeah.
So when you were explaining that IR, the rational minus 0, what was that point?
Okay, so
is
the
it
thing is
subjective function? I was
extending
asking.
to I got your question. So extending to 0 positive means we are tending, like x is tending from this side, from the positive side. Okay, positive x-axis, and x is tending to 0 from the negative side means from this side. That means from the left hand side. Okay.
So what you concluded after that about the subjectivity
Yeah.
and about the injectivity, I'm
Yeah.
asking that.
Okay. So this is clear, right? Infinity and minus infinity. Okay.
This
So
is clear.
what I concluded is we can take codomain as real line. Okay. So if the codomain is real line, then the function will not be onto, because the point 0 won't have any pre-image. Right?
Okay. Okay, ma'am.
Let me write it as a note. I am just writing it as a note. If the codomain code is R, that means real line here, then 0 has no pre-image. So f from R minus 0 to R, the same f, R is not onto. Okay, this is the first thing. But if you take the codomain as real line minus 0, then we are excluding the point which has no pre-image, then the function will be onto. Okay.
Okay, ma'am, got it. So basically, it's an injective function also. So is it?
It is an injective function.
Okay.
Okay. Any doubt? Anything?
Mom, I have a doubt. See, for example, you have like f is equal to 1 by x, right? So what we did, we took minus infinity to 0, union 0 comma infinity, so that in between 0, we are not taking anything, right? So how do
Like
you...
that means we are not taking the point 0, because at the point 0, we cannot define the function. That means 1 by 0 is undefined, right?
Yes, yes.
Yeah, that is excluding the point 0 from the domain.
Okay.
So 1 by 0 is not
yes.
defined. So exclude 0 from domain. Okay.
Okay.
Yeah.
So, like, I am not able to identify, like, for example, now you gave this, like, minus infinity to 0. I understood till there. Then how do you define it as like 1, 1 or onto on what basis? Like, let it be any equation I'm able to solve. Like, after that, I'm not able to identify what is that actually.
Means 1 or onto or what, right?
Yeah.
Okay, so simply onto, what I said, ki onto means every image should have a pre-image, right?
Yes, yes.
So if I have R, then 0 has no pre-image. We can check it, right?
Yes.
So if I have R as the codomain, then the function will not be onto. But if I have R minus 0, then we don't have any disturbance. In that case, the function will be onto, right?
Onto. Yeah, yes, ma'am.
And suppose you want to check for 1, 1, then again, I will suggest you just have to like find it by the definition. So you will start with f of x1 equals to f of x2. So in the next line, you will get 1 by x1 equals to 1 by x2. In the next line, you can conclude x2 is equals to x1. This is a definition of 1, 1, right? So it will imply that the function is 1, 1. Okay.
Okay. Got it, ma'am. Thank you.
Yeah. Also, the second, once you have graph of a function, you have the horizontal line test, right? Which says
Yes.
that, yeah, if you draw the horizontal line and if it cuts the graph of the function one time, then this will be 1, 1 function, right? So in the
Yes.
graph also, you can check it will cut the graph only one time. If you draw any horizontal line here, right?
Yes.
So from the horizontal line test also, we can say it is a 1, 1 function. Okay.
Got it, ma'am. Thank you.
Yeah. Any other doubts?
I'm little bit confused, ma'am, for onto function. Especially for root type question, for this type of
Okay, so
questions.
typically if you have some function, okay, just let us take a simple example. Suppose you have x square, okay? And we know that it is, suppose it is from R to R, okay? And let consider ki you have to check whether the function is onto or not, okay? No, this is not an onto function, but we check. How can we check? Be the procedure, okay? Okay. So the first thing is, if it is onto, then for any element in the codomain, we should have a image in the domain, right? So for any element, we will start our answer. We will start checking it from any element, any arbitrary element in the codomain R. Okay. Okay. Then we have to check whether there is a point which can be pre-image of this element. Okay. So just say, like first we will assume there exists x belongs to R domain such that the functional value of x is equals to y. Okay. That means x is pre-image of y, right? This is our assumption. Okay. Okay. So in the next line, we know the function. So that means we will get x square equals to y, right? And in the next line, we will get x equals to root over y, right? But what we know that x belongs to a real number. So if you want to define x, then if we want to get real x, then y should be greater equals to 0, right? Right? Otherwise we will get a iota and x will be a complex number. So which is not possible, right? We will get x as complex, which is not possible.
Ma'am, I will not understand. For repeat this.
Yeah, sure. So the range will be basically real r plus. That means positive real numbers. So what? I'll just recap
when x equal to root y is coming, how to check?
Okay, so this is some method.
For putting values.
You can check. I mean, the first step is we took a arbitrary element from the codomain, right? Then we assume that there exists a x belongs to R such that f of x equals to y. Okay, this is our assumption. So we know what is f of x. Put the value of f of x. So we will get x square equals to y. And in the next line, we know that it will imply that x will be equals to root over y. Now we can see that if y, because we took any real number y, but if y is a negative number, then we cannot define x, right? That means for a negative real number, we cannot define any pre-image, right? This implies that for any negative number, we cannot define.
When complex number are coming, it is not defined.
Yeah, because we need x from the domain, that means real number, right? Right? That means for any negative number, we cannot define any pre-image. That means the function will not be onto. Okay, that is how we can prove the function is not a onto function. Okay, this is a typical method you have to follow this method. Okay.
Ma'am,
Yeah.
what if y is 0, ma'am?
What?
Ma'am, so y can exist as 0.
Yeah, if 0, then x will be 0. 0 square is 0, right?
Yes, ma'am.
Okay. So let us.
Ma'am,
Yeah.
for this question, function is defined from R to R and to N.
Yeah. Yes.
R to R. Okay, ma'am.
Hello.
Yeah.
Ma'am, I have a question from activity 10. May I ask?
No. Activity and all the questions we will you can ask in the open session. Okay. So
Yes.
this is not the open session. In Tuesday session, you will ask all the all your
Okay.
doubts. Okay.
Ma'am, this class is till
Thank
when?
you.
Ma'am, when I have open session?
This class was up to 10, but we are over time, I know, but we have to also like take your doubts, right? So yeah, this is fine. Okay.
Ma'am, where you are going to upload this PDF?
Daddy.
Yes,
I
ma'am.
will.
When
I
this
will.
How to
class
access
will
this
end,
PDF?
this class
will.
has to end by 10. When is this class up to end, this class has to end by 10. But I'm going overtime because I have to clear all the doubts.
Ma'am. Hello.
Yes.
Ma'am, when complex number are coming in any question, it will be not defined.
Yes, because for this course, yes, because we are working on the real line, right? So if you are finding anything that is not from the domain,
function is going n to n or integer to integer, then what happen? It is defined or
like
not
if
defined?
you are finding something, some number which is not a member of the domain, then you can directly conclude this is the particular image has no pre-image in the domain. Okay. Okay.
When x equal to is coming element is not present in a domain, that's not defined.
Yeah. Okay. So yeah, don't worry. We will solve. We have some examples, functions 1 and onto functions. So we can go through these examples. Okay. This is our next example. We have this. This is our function, and you have to check whether this function is 1 or not. So you know how to check a function as 1 or not, and just you take your time. You just try to check it and let me know whether this function is 1 or not.
No, ma'am, not 1, 1.
Why?
Ma'am, because when n is odd, ma'am, for example, let's say when n is 1.
Yeah, 1.
This is
1
The
is not
second one
equal
doesn't
to,
have.
right?
It produces the same output, na madam. If it is 1
Ma'am,
plus
for
1 divided by
every
2, it is 1.
Yeah.
Ma'am, for every two number, it has one output. For every
Right.
two output, for every two input, it has one output actually.
Yes, right. Yeah. So basically, if I take a particular example, 1 is not equals to 2, but their image is same, which is 1, right? So this is not a 1, 1 function,
So,
right?
ma'am, if we wanted to theoretically prove it, we have to prove it like n1 plus 1, 2 is equal to n2 upon 2, like that.
Yeah, I mean, no. If you want to prove a function 1, 1, then you will prove it theoretically. But if you want to discard it, then you have to find an example. Always take this thing in your mind that if you want to prove something, then you have to prove this following these steps. Okay. But if you want to discard something, then you have to take an example.
No, ma'am, suppose I have to prove it theoretically. So it would be n1 plus 1 upon 2 is equal to n2 upon 2, na, ma'am? By that, na?
Yeah, yes. Like that means that you have to take the functional values as same.
Like n1 plus 1 upon 2 is equal to n2 upon 2, na?
In that case, because you have the function is defined for even and odd differently, so you have to consider all the pairs differently. That means you have to take 3 different pairs. You have to take odd, you have to take even, and you have to take odd even.
Write it and tell like in a very fast way.
Yeah, so I just write it. So if you want to prove it, suppose this is on 2, and suppose you want to prove it on 2, 1, 1. So you have to take 3 different things. That means even. That means some n1 and n2 such that n1 plus 1 equals to n1, n2 plus 1 by 2. This is one case. And from here, you have to imply that n1 is equals to n2. Also, you have to take n1 by n2 equal to this. N2 is by 2, and then you have to conclude n1 is equals to n2.
Ma'am, conclude or we have to negate that?
Yeah, that is same thing.
Okay. We have to
Concluding
negate
something
that,
and
n1
indicating
should
something.
not be equal to n2.
Yeah, and the third thing is you have to also check for this. Okay. If all the 3 definitions are satisfied.
But the third case would just by
Would
saying
not-
it, that the third case would not be possible. So just by
Ma'am,
third
first two cases would be satisfied, ma'am, but the third case
on
wouldn't
through
be
that it's
satisfied.
not an onto, like
Yeah.
it's not a 1-1.
Yeah. So
Because
the
in the
first
third
2 cases you can satisfy, because so you can conclude that if you have any 2 odd number or any 2 even number, then their images will be different. But if I take 1 odd number and 1 even number, then we cannot conclude that their images are different all the time, right?
So from the third case, it's quite visible that
Yeah, this is not a
n1
one
plus
one function.
1, n1 plus 1 is equal to n2, so it won't be possible.
Yeah, right. So from the third case, you can clearly see that the function will not be a 1, 1 function. Okay?
Okay, ma'am.
Yeah. Okay, let's move to the next question. This is again you have another function and you have to check whether it is a on-one function or not. Okay, so yeah, same thing. You have to do it.
No, ma'am.
Why? Then once you are saying no, that means you
1
should
and
have
2.
the example.
1 and 2.
Yeah. 1 and 2. But f of 1 is equals to f of 2, right? So this is not a 1, 1 function. Okay. Okay, is it fine? Any other doubt?
Ma'am, we instead of n, we are assuming no 1, 2, and some other number, right?
Examples actually. Okay, we are
If the
examples.
question comes like that, there are two n is odd and n is even. Mostly, I guess it's 100% that it won't be a 1 function. Do you agree?
Yeah.
Because if even and odd comes like that, it cannot be an 1 function because
No, you can have no n plus 2 if it is there when n is odd.
No, this is not the case. I mean, if even an odd is there, then the function will not be 1. This is not the case.
Madam,
If
any
you
number
can,
actually you have here, if you add it with 1, it becomes an even number. Correct, madam?
no, yeah, that
No,
is
if
true.
it is 1
But
is there,
it is
if 2 is
always
there, n
exactly.
plus 2, n plus 2, n is odd and
Exactly.
root. Yeah.
yes, ma'am, it's
In that case, you will
understood.
not able to take this. Okay. Yeah.
Okay, ma'am.
Let us move to the next question.
Just 1 second. If we have this sort of functions, can we throw some random numbers depending upon the category? If it is a real number, a real one, or a
Yeah,
natural
I mean, you just like suppose if you want to discard something, so you have to take an example. So you will take any number from the domain which is not satisfying this, like which can be an example to discard this.
Okay, if it is a natural number, we have to take from 0 to 3 or
Yeah,
0 to
if
5,
it
like
is
that.
like whether the domain is a real or natural doesn't matter. You always have to take some number from the domain. Okay, if the domain were a natural number, we would have take the element from the natural number. Okay.
Okay, madam. And one more thing, can you please solve this sum with the roots so it will be easy for to
Which one?
this one, the one Q6.
Yeah, sure. I will solve. First, I will give you some time to solve. Here you have to calculate the domain. That means simply you have to calculate the region where we can define the function. So you have to take the region where we can define the function. So anything, what is in your mind?
I think it should not have -5, that is for sure.
-5 or +5?
+5.
+5.
Yes, ma'am. +5 should be there, and the x value should not be less than -3.
I think option A will go.
Right.
Option
Very good. Yeah, you are getting this thing. Yeah. So the thing is, in order to define this, first of all, this portion should not be equals to 0. That means x minus 5 should not be equals to 0. That means x should not be equals to 5. And the thing is, in order to define the root, under root portion, we should get this is greater equals to 0. That means x should be greater equals to -3. Right? Okay. So our domain will be x greater equals to -3. X greater equals to -3 and including the 0.5. That means option B. Fine. Is it fine?
Okay, ma'am.
In the question, x minus 3 is given. It's not x plus 3. And, ma'am, question is a root under x minus 3 upon x minus
This
5.
is plus. This is not minus. I can see it as plus.
Okay, ma'am.
This is under x plus 3, right? Not minus.
Yes, ma'am.
Yeah. Okay, so I guess it was the last question. Yeah. So we can, the option is B. Okay. Okay. Any doubt?
One final thing, will we have this sort of questions in the
Exam.
or it will be very difficult?
Yeah. No. The question is not difficult. The question, you will face a moderate level of difficulty. Okay. It will not be so hard to solve. Like if you have the concept, then you can solve the question. Okay. We have maintained the difficulty as moderate level. Okay.
Okay, that is going to be the same syllabus only, not changing.
Yeah,
Fine.
similar.
Ma'am, one thing,
Type of,
if if it is considered a natural number, should we have to count from 1 or should we have to count from 0?
0.
Even in maths?
Yeah. So for this course, we considered the natural number from 0. Okay. We will follow the Python rule and we will consider natural number.
But there was some person in TA, the person who took the TA, he said no, in maths also you can take it from 1.
No. You will consider natural number from 0. Okay. Not from 1.
The Python thing, because in Python it is
Yeah.
considered.
Yes. We will follow, because ultimately you have to be like familiar, you have to be comfortable with this, and this mathematics things are just to create your base, right? So we will follow what is the ultimate. That means you have to follow this thing. So we will follow this thing from the beginning. So just this,
Okay, ma'am.
let's clear
Ma'am,
this
if the
one.
class ended, can we leave?
Yeah, I will just share the PDF and you can leave. Just wait for some time. Let me just create the PDF and share it. Then I will share it in the chat box. Okay.
Okay.
Just wait for some time. Okay. Again, if you have any other doubt, you can ask in the open session. Also, we will pick your doubt from activity questions and all in the open sessions. Okay.
Okay.
Yeah, just wait for some time. It's taking some time.
What is the difference between open session and live sessions?
No difference. I mean, open sessions are also live sessions. Okay, basically in open session, we will pick your doubts. It will be all about your doubts. Okay, I shared the first file. Can you see it?
Yes, ma'am.
Yeah. Okay, just give me some time. I will share the second file too.
I think in this dashboard, what we are saying, this work with instructor sessions for none of the subjects, it's there. I was checking for statistics also. There also solve with a session. It's not there. It's all blank.
Where?
In the dashboard where we see solve with a session, it's blank. So we
Okay,
got
so
these questions only after you shared the PDF. Otherwise, if we go to that link over there in the dashboard, it's blank.
okay. No, it's fine. If you need the PDF after the class, I will share the PDF. And if Samiksha will be taking the class, she will also. You can also ask her to the PDF. She will also share it. Okay, so you will just get the PDFs. Don't worry. I just shared them. Did you find it?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay,
Yes,
I
ma'am.
shared both the PDFs, so you can download them from here. Yeah. Okay. If you have doubt, you can ask. Otherwise, you can leave.
Thanks for the session, ma'am.
Yeah. Welcome.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Okay, good night, ma'am.
Thank you, ma'am. Good night, ma'am.
Yeah. Good
Thank
night.
you
Please
so
give
much for that.
ma'am, please give 1 minute to download it.
Yeah.
Yeah, ma'am.
Yeah. Sure. I'm waiting until you all leave.
Thank you for the session, ma'am.
Thank you, ma'am. Have a
Thank
good
you.
night.
Good night, ma'am.
Yeah. Welcome all. Good night to all.
Ma'am, I have a problem in opening the file. It is showing
Okay.
error.
That second file cannot be opened.
Is it so?
Yeah.
Ma'am, this will available in the calendar.
I will upload this in the calendar too. So you have to download the file maybe.
Yeah, I downloaded and opened it. First one opens. The second one is not open.
Oh,
I
second
can
one
see
open for me.
it is opened. I
Yeah,
can see.
yes, ma'am. Second for open for me.
Yes, it should be open. Like you shouldn't get any problem. Okay,
I
you
I
just
think
try
first of all
if it is.
download then open.
Yeah, I just download. Wait, I'll
Okay,
try.
you just try to download and open it. If it is not happening, I will share it in the calendar too. Okay.
Ma'am, where is calendar?
Your Google Calendar.
Yeah. Okay.
Yeah. Okay. So if you don't have doubt, you can also.
One doubt I have, like this kind of maths will also come in the third and fourth year of BS and BS engineering, like high level will come.
Am I audible? Hello.
Yes, madam. You are.
Yes, ma'am.
Yeah, I maybe I got disconnected because of some network issue. Yeah, someone was asking some doubt. Did you lift?
Ma'am, I was asking that like the mathematics will also come in the third and fourth year, like
No, maybe.
no.
I'm not sure about it. I'm not so sure about it actually. Like yeah, I can not say you anything surely right now, but yeah, in the next class I will ask someone and then let you know.
Ma'am,
Okay,
our next class will
so
be on
Yeah.
Sorry to interrupt. Ma'am, our next class will be as per our calendar, right? Or no, will
Yeah,
you
yeah,
not
yeah.
provide
We will
Can
follow
you
the
upload
calendar
this
strictly.
PDF?
Ma'am,
Ma'am,
I'm
can
not
you
able to
upload this
download the
PDF?
Yeah.
file, both of them. Can you guide me like how to download it?
I mean, which
Ma'am, I'm
file?
also not able
The
to download it.
okay, okay. I will upload those two file in the calendar. Okay, you can download it later also.
Okay, ma'am.
If not, just let us know in the
So,
upcoming sessions too.
so is there anyone who can download? Is there anyone who is able to download both of them or only
Yeah,
one?
there may be someone.
I've
Yes,
already
ma'am.
There may
first
be
file
Also
some.
not
to
first
I've
file
download?
shared
can
the
download.
attachment.
What you are
I
saying?
download all the file. All the 3 file is able to download.
There are two only. The one I have sent to all people as they have not, they're not able to open the file. So I've given one more. So two files again I've shared it with you. You can download. Madam, do we have a session tomorrow?
Yeah, tomorrow maybe we will have a session from 4 Hindi session.
At maybe approximately what time, madam?
4 to 6.
4 to 6.
Yeah.
Achha.
Okay. So let us in this
Ma'am,
session.
could you please upload this PDF in the calendar
Yeah,
as
I
well?
will upload. I will upload in the calendar. Sure.
I'm
Sure.
sorry to interrupt
Okay.
you, ma'am. Ma'am,
Yeah, sure.
in calendar, there's no any information about tomorrow classes for math. So will we receive any kind of
Yeah, it is
link?
not yet updated. Okay. The thing is, it is not yet updated. We just decided it today. So if it is the case, we will update it and we will send you emails. You can check it. If not, then you will not get any email. Okay. So the thing is, you may have some session. You just try to check it. If there is a session, you will get the announcement.
Okay, ma'am. Thank you.
There is one thing, the file, there is some technical glitch. So can I share my screen if you can like see it?
No, you can. You are not allowed to share your screen. So, but you cannot. Some of you maybe cannot download the file. So I will upload the file in the calendar so that you
Can I
can
share the
download it from
screen
the
if it is
calendar.
possible? If it is possible, if someone can guide me.
No, you. No. You cannot share the screen. Actually, no. Like if you are not a co-host or host, you cannot share your screen. It's not allowed for all. It's a technical thing, no?
Because ma'am, when I download the file, I download in my desktop.
Yeah.
So I'm not able to see it on my screen.
Okay. So what is it showing? Like something black or what?
No, it's not even saying that. It's not even. I'm not able to find it like even in my own desktop. When I download it on the screen, it is saying it's been downloaded. But when I go to my desktop, my screen, I'm not able to find it. The file, I guess. I don't know.
You can check it once again. Also, I will share the file on the calendar, so you can also try to download it later.
So the okay, even
Okay, ma'am. So
Ma'am,
today class is over
Also,
now.
yeah, class is
ma'am,
over.
I have
Yes.
one personal doubt.
Mm-hmm.
TA internship
Okay.
get in foundation level or diploma level?
What?
Ma'am, TA internship get in a diploma level, yeah, pass out of yeah, foundation level. Sorry, foundation.
Okay. So I am not very sure about it actually. I cannot guide you about it properly. You can ask someone else about it. Okay.
Okay.
Okay, so let us end this session. Let us not take it too much. I will upload the file in the calendar. You can find it. Otherwise, in the next session also, if you want, I will share it again. Okay. Yeah, so I'm ending the session. Okay, so yeah, good night to all of you.
Okay, good night.
Yeah.
Oh, hello. Is ma'am there or has she left?
Left.
Hello, Ravi.
Mhm.
Ravi Sumani ji.
Mhm.
Yeah. Is Ravi Sumani ji able to listen to me?
Yes, I can tell.
Yeah,
Tell me.
yeah. In the last session, I asked the teacher that I'm more interested to mathematics. So you only suggested me for that, na? For the mathematics course in
Yes,
this.
yes, I suggested it.
Yeah, actually, I took this course by mistake. I am more interested into mathematics and also which actually I have done my 12th and I have done my 12th. I have done my MA in English and my 12 percentage is very low, and my maths grades are also very low. So which institute shall I go? Because
Is it like above 50 or above below 50?
my overall percentage is above 50, but my maths is less than 50, I guess. So
No, they are asking about they will ask about your overall percentage.
no,
The
no, overall
50%
is
above.
57. Overall is 57 actually.
The thing is that actually, see, if you wanted to do in an online mode or maybe this is the only course. I mean, if you wanted to do an online mode or maybe IIT Guwahati, that BS course. Otherwise, if you wanted to go, I mean, enroll in yourself into a regular program, then it's better to go Indian Statistical Institute or maybe Chennai Mathematical
But
Institute.
they'll see the percentage of 12th of maths and I
No,
guess.
no. They will select you on the basis of entrance examination. You have to give their entrance
Yeah.
examination.
Both of them.
Yes, they have.
Yeah, both of them.
They have taken. For example, Indian Statistical Institute, they are conducting their own entrance examination. So you have to sit in that entrance examination. Then after that, once you clear the entrance examination, their cutoff list, then they will call you for interview. You have to crack the interview as well.
Okay, and you said that there is an
So that two institutes are the best if you wanted to go for only for maths type of program. BSc BS in mathematics. These two institutes are the one of the best institute in India.
Indian Institute of
For-
Statistics and Chennai
No,
Maths.
Indian Statistical Institute, ISI.
Okay.
That's
And
not Pakistan ISI. This is Indian.
okay. Okay. And the second one is that in Chennai.
Yeah. Chennai is a mathematical institute.
Okay. And if it is
See,
online,
the faculty of that CT program.
Yeah.
He is from Chennai Mathematical Institute.
City.
What's the name of faculty?
Teacher city.
I forgot. Yeah, cities. That professor. He's from Chennai Mathematical Institute.
what city?
No, city.
Who
Computational
professor
thinking.
teacher city?
Okay.
Computational thinking professor.
Okay.
If you already watched that videos recorded video,
Okay.
there is a professor, right? Two professor was discussing about something, right?
Okay.
One is from IIT Madras and one is from Chennai Mathematical Institute. What is the name of professor? I forgot the name of professor.
Okay. And you told if I have to do the online, then there is IIT Guwahati and this one. And IIT Guwahati is also more about data science and not about mathematics, I guess.
Yes, same thing. I mean, if you that is also see statistical few part in that data science in few parts like moreover see this the earlier this data science work used to do by statistician. Okay, so I mean I'm talking about the 10 years ago when this course is not been instituted if in by any institute all over the world, like earlier in 90s, in early 2000, this works done by the statistician. People used to call them statistician. Now they have changed the name as a data scientist. So if you see this, I mean, in basically in data science, you have to much know about statistics. Few part of the few part algebra. You have to know the algebra to become a data scientist. Like algebra, parts of the mathematics I am talking about, and moreover, this is overall. You have to emphasize more on statistics only and programming because you have to do the coding to clean the data. So that is the reason. I mean, you have to you need to know the programming languages.
But I wanted to go into more mathematics.
Yeah, more if you wanted to go for a more mathematics, then be a statistician because there are lots of jobs available after completing your statistics program. Like as I told you, Indian Statistical Institute after completing, there are many, I mean, jobs available after completing BS in mathematics or BS in statistics. There are two programs in Indian Statistical Institute. One is BS in mathematics. If you go towards mathematics line, or if you wanted to I mean, emphasizing on statistics, then they are allowing you to do BS in statistics.
But it's not online course, I
No,
guess.
it's not online course. It's regular program.
Online course of particularly mathematics and a little bit of programming.
Yeah, then you have to go for any online program like MIT University. There are many online universities are there which are offering BS in mathematics or something like that. But do you have a maths in 12th?
Yeah, I had maths in 12th, but the number was less because of some issues. But
Okay, so like even IGNO also offering BSc in mathematics.
which
But IGNO is online, I think.
who's
Yeah.
offering?
No, IGNO is not online. IGNO is distance learning program. They're not
IGNO
offering
is offering that course of BSc in mathematics, kind of.
BSc in mathematics. IGNO, Indira Gandhi National Open University.
Yeah, it is. But I wanted a course which has most mathematics, but it has some part of coding, mostly Python.
Yeah, all nowadays, those who are taking BSc in mathematics, many of the institutes they are offering you to learn a one programming language, at least one programming language. They teach you they teach you at least one programming language in that course. So you will get it. If you check the list of those institute, you will get it get all the information.
Okay.
in the
And
institute.
by the way, you are from which background, like what you have done?
I am from biotechnology department.
Okay, like what is your age, by the way?
I have done biotechnology.
Okay.
So the thing is that if you go to maths, like towards only for maths, then better you should go for like don't go for a distance learning program. Better if you I mean if you can take out time, then go for a regular program.
Actually, I
My
need job also. I am also at a peak of my age now. I should do some job also. So that's why I can't go to files.
then opt the course whatever you have opted right now, that this BS degree program. I mean, go with that flow. Go with that program.
But
My suggestion is.
But in the third year, it's more of coding, and I don't think there will be mathematics in third year and fourth year. It
Yeah,
would
coding. That's why I told you coding is necessary to clean the data. How can like there are huge number of data. See, if you go to any company or maybe in a job, or they will offering you the huge number of lump of data. So
But
how do you
that's
going
the
to clear?
part of the data. But that's the part of a research part of the data research team, because AI is vast. Some people filter the data. Some people apply that ML thing.
That is the reason data scientists doing the ML thing. Majority of see, data scientist work is above the machine learning engineer. Machine learning engineer will clean the data they will apply the coding and algorithm. After the cleaning the data, they will given that data to data scientists. Then data scientists will done all the what are the prediction level is there. So they will going to see all those data after that. The entry level job is data analytics. Data analytics is nothing but they are like there is one is predictive analytics, one is descriptive analytics, right? So descriptive analytics done by this data analyst. That means past data. Company has those past data. They are only cleaning the data, and they are showing what are the things happened last historical data last in the company. And this data scientist, this machine learning engineer, they will do the prediction, next prediction, what is going to be happen after seeing those historical data, what is going to be happen. For example, if they are running marketing campaigning, so what is going to be happen next.
But I guess if I go for a BSc mathematics, then this job, like this course has more job opportunity in upcoming future, I guess, data science and ML, than being a mathematics kind.
No, everything has their own pros and cons. Like mathematician job will not going to be. I believe next till 30 more years, mathematics statistician and mathematician job will not going to be finished.
Okay, you're from which city, brother?
I'm from Assam, basically.
Okay.
Assam.
Yeah, Assam.
Well, last year I went to Assam to Kamakya Devi Mandir, by the way.
Yeah. Do you have any question? Because I need to go actually right now.
You can share your
Okay.
contact. I'll definitely connect with you.
Yeah.
Acha, okay. 1 minute. I have one doubt. Who a student get a TA internship in a foundation level, yeah, diploma level?
Foundation level also, diploma level also. If you score 90 above percentage or maybe 85 above, something like that, they will see your mark. Based on that, you can apply for the TA.
Can you share your
How
number
to apply a
again?
TA?
Number is in the WhatsApp group. I have shared the WhatsApp group link, right? In the chat box.
Okay.
People don't
Give
see
me.
it.
You
I
have
want
your
to.
personal number?
Yeah, join that program. That is my personal number.
Where have you?
I've shared the WhatsApp link group. That
Then link is like buzzard. In link, a lot of people are there. But if I wanted to contact you for some time, like
no,
Yeah.
I am the admin of that group. I am the admin of that group.
you are into which?
Which group? Which group?
The WhatsApp group. I have shared the link
Okay.
in the chat box.
So
Many
you are
people
a
don't see.
qualifying
There
student
is
or
not a
you are
link.
a diploma student, brother?
No. I have last term I have qualified the exam, but I unfortunately and some problem arise, so that's why I didn't join the program
Okay.
last term. So
So
this term
But
I
there
am.
is not a link.
so basically, if I give this exam, the qualifying exam this Feb, and
Mhm.
like I can join the program till what session I can join the program next year also, na?
No, after you once you qualified the exam,
Mhm.
you will going to get two more term.
Three.
Uh,
Three
yeah,
term.
yeah, that's what I'm saying. This term,
Yeah.
next term, the whole year.
Yeah. Whole
You
year.
So
you
basically,
have
the March term, the September term, and also the next year's January term. You are
no
saying that?
till
No.
December term.
Okay,
You
till
Yeah.
have to
December
take
term.
admission before this December of this year. And
Okay.
other,
Before this,
yeah, you have to
that
take.
will be September term,
uh,
na?
yeah, September. Not that's what I'm saying. This term, next term. I mean that is May term and September term.
Also,
Are you
you are
Uh,
sure?
not a qualifier. Yeah. Sure.
if you not take admission within this year, then you have to again next year you have to give the qualifier exam again.
The main thing is
Yeah.
I was more interested into math. Now, if I like my 3,000 rupees is like wasted and all. I don't know. Shall I
Not
go
is
for the
going to be
maths course or
wasted.
this course?
See, I believe I'm very optimistic person. So I believe once you invest it, this is kind of investment. You are learning something. You're not going to be waste this money. Many people you have joined. Many people. I mean, many people you contact with many people within this degree. Then you have learned something from your professor, your TA. So nothing is going to be wasted.
But here is not a link.
Hmm?
Here is not a link.
What is the link?
Please send it again.
Yeah, wait just a second. Let me copy and paste it.
Okay.
I don't understand why there are so many groups and every diploma person who is going to the next level, they are creating group. Mostly they are spamming. But what is the main purpose besides
See,
help? Besides
join.
helping, what is the other
See,
purpose
join.
of people?
That's what I'm saying. Let me clarify. Join only those group which is like their admin is very I mean kind of studious person, or maybe like in
Is
I
the
mean
purpose besides helping? Why there are so many groups? Like they are mostly they're
helping to
spamming.
contact with people, discuss about. See, for example, I have a doubt in, in maths one question, for example. Okay, if I share that question, like I'm not able to solve this question. So if I share this question with in a group, so someone like somebody have a unique answer. So he will share his answer. So discussion is very necessary, because after all, this course is
That is fine. That
online
is fine.
course.
But can you give the graded answer, the answers of the graded questions in the group? That is the main
Yeah,
purpose.
people are sharing. People are sharing. Those who have
Or,
solved.
oh, yeah.
That is the
Already,
main purpose.
so many students are sharing a graded assignment direct answer
Yeah, direct
at the
answer.
last date.
Please
Yeah.
join group like whatever I have shared it, right? So
Okay, okay.
join only those group like who are not doing advertisement. There are many groups. People have created many groups. Why they are creating many groups? Because once you join that group, they will get your phone number, your email ID. Once they will you get your email ID and phone number, they started sending you this fake job offer or fake internship offer.
So how will they
Yeah.
get my email
Getting a lot.
ID? They can get my number, but how will they get my email ID through what? Through the meeting link?
Because somebody will share the class link class link. So okay, so once they get the class link, they will join this Zoom session. Once they see the Zoom session, in Zoom session, many people, if you see, many people have logged in through their email ID. So once they
But
get
how
it,
will
their
they be
email
able
ID.
to connect my number to that email ID? How they'll get to know that this email ID belongs to this number?
No. Number is separate and email ID is separate.
Okay.
They will send message to your email ID, and if necessary, they will send you, once they get your number through WhatsApp group, they will send in your phone number.
But email ID, everyone is like available because through the Google group, when one person can share the doubt, can also share a lot of groups that thing. Because in the Google group, through Google group, you can.
That's why I don't like let people to like in my group. I don't let people to I mean discuss unnecessary things. Only course related to topics. If you have any, see, I have created many groups. There are chit chat group also. There are chit chat group also. If you wanted to do a I mean gossip, you can go to that join
But
that
what
group.
is your purpose? Just for helping, or you also
Yes,
you?
for helping only. I don't do such a advertisement and such kind of things.
I guess you
So,
could have done it 1 year before because now it's a lot of basad here.
but that means so in our group.
I mean, earlier many few people had joined this course. Now a lot of people.
Yeah. I know. Many people have joined, and many people wanted. See, they are taking money from third party. I have seen. I have talked with some people, and I I got to know that many people have creating like if you see, they have added many people. I mean, a thousand number of people. Okay, so what they are doing, they are taking from third party. They are taking money from third party, and after that they do the advertisement in their own group. So that is very bad, I
Okay,
believe.
third party is
Last time
something which
I
is selling
joined
the
a
course and all.
yeah.
That for
Last
example,
time
any institute is giving money to that person, okay, that admin, and he will like advertise in for that institute into that group. So many people, for example, if you wanted to learn coding, Java programming, for example, okay. So many people, many institutes are there in India right now offering online programming coding also, like 1,000 rupees, only for 1,000 rupees, only for 499 rupees, something like that. So you can
And by
have.
the way, okay, I got it. But how is the Guwahati course of that data science that you what telling about? How's that course, Guwahati course, that SM IT Guwahati course?
Like this course is far better than I believe IIT Guwahati course. IIT course, Guwahati course, they have shared the platform with Coursera. If you know about the
Yes,
platform Coursera, if you
yes.
go to Coursera, you can see the IIT Guwahati has shared a, I mean, signed a memorandum with Coursera, I guess.
Yeah, okay. But for the mathematics course, the two institute that you told me, like I have checked their sites and the ISI institute was saying that there has to be some percentage in 12th and something like that.
Okay, I didn't check it, but maybe they will see the Chennai Mathematical Institute.
Any good institute in like all over the world through which has some part of coding and like good mathematics application, which is like if you can suggest
I
me.
can suggest you many courses, but the thing is that those are into a dollars. You need to pay dollar. Are you ready to pay 10 lakh,
No.
10 lakh rupees or
Obviously, no, because there are some courses free on Coursera and Udemy. So I thought through that.
no. The courses are di- you can't compare degree with the certification.
Okay.
Degree. Certification is certification.
So isn't there
Certification.
kind of a
People see,
course?
for example, somebody has completed his BTech and somebody has completed his MTech. Okay, he need to upgrade himself. So for them, certification is good. Okay, because he need to get a promotion. For example, he is doing a job in a company, so he need to get a promotion. So that certification will help him. But initially, if you are going for a job in a company, you have to have a like a degree, at least a bachelor level degree.
And
Are you
I,
getting?
I got it. Earlier, I was confused. Shall I go for IGNOU BSc or this course because I was more interested into mathematics. Then I opted for this course because it has more vast kind of opportunity in job. What do you think? Shall I opt for this course only or shall I go for IGNOU in mathematics BSc?
See, like what I can say, I can suggest you, but I can't like tell
Because
you.
I'm more interested into mathematics and this is mostly it is only coding and
See,
coding.
if you don't love coding, like if you don't want to go for a coding, you have because as a data scientist, you have to do lots of coding
See,
in a
my
company.
interest lies in more in maths and some part of Python through which I can imply that maths into the coding.
Then
That
that's what I'm saying. If that is your that is in your mind, then go for a like BSc in mathematics such kind of program, because in those program only one to two subject you will get a coding subject, and rest of the
yeah, but
subjects you will
then
get
through this course I'll get better job na than that BSc IGNOU course of maths.
Yeah,
you
first of
you
all,
you wanted to
first of
you
all,
wanted to I mean